Hello and welcome to day 2 of Qubes OS Summit 2024.
Oh, welcome. We have some.
So it's second day of the event organized by 3MDev and Invisible Things Lab. And let's start with our sponsors. So first of all, let's thank our Freedom of Press Foundation for sponsoring the event as a platinum sponsor. And second platinum sponsor, Malvat VPN. And we also have two silver sponsors, NovaCustom and NitroKey. I guess Wesel. So thank you very much for sponsoring. Yeah. Okay, so today agenda looks as follows. Like we will quickly go through the welcome. Then NovaCustom will have presentation about V54 and V56. I guess V56 was announced as a certified.
It's already announced as Qubes certified.
Yeah, so I guess we will get more information about the certification process and what's going on with V54. Then I will try to tell you about the state of the UEFI secure boot, despite there are much smarter people on the in the room than me. But I try to gather all the information in one presentation so you know where we are, and then maybe we'll have short discussion where we're going. Then GPU passed through my personal experience from Neo Vutran, and after that we will have Francisco talk about joys and sorrows of multi-VM app development. So I guess this is based on experience with SecureDrop. After that we have, of course, the most important part, the lunch break, 90 minutes, and when we get back we will have a design session with Jan from NitroKey about the future of Major Boot in heads, or as heads or some other alternatives. Then Thierry will talk about safe disk state as a firmware service. I'm not sure what's precise, but this is this a design session?
That's a question for Thierry, but
Thierry probably is still sleeping, but hopefully he will wake up. And then Piotr will talk about the devices in Qubes. And finally, like at the end of the day, we will have two talks. The rolling release in heads, there is some discussion how to deal with that and how to make. We have quite of arguments yesterday, but hopefully we'll get to some consensus today. And then last talk from Kenneth. I don't know if Kenneth is from Freedom of Press.
Yeah.
So Kenneth is from, I didn't know because he didn't wrote that in the description. But then this would be about Qubes ready to install. This will be remote talk. And that would be it for today. And of course, tomorrow we will have hackathon, but I will announce that at the end. Any questions?
Yeah, but if you have some ideas during the talks, what you would like to do tomorrow, yes, please remember that we will collect. We'll have some place to write it down or some flip.
Yeah, we can find some.
There is in the corner, so
yeah,
we can use that, I guess.
Yeah, we can start writing down the ideas for tomorrow hackathon.
Yeah.
Okay. Any questions? No, then we have like a
10 minutes.
10 minutes break.
Perfect.
Thank you.
Hello everyone. Today we will introduce you the new V56 series of Qubes OS laptop, and we let you know your plans in the near future. First of all, a little introduction about the company. We are NovaCustom. We have 3 guys here. We established in 2015 and we called NovaCustom since 2018. We are focused on customization of the laptops. For example, we do custom laser engravings. That's it, yeah. With the Shadow Cobalt firmware. We support Windows and Linux, or even both at the same time, as a dual boot setup. We are focused on privacy and security, and we highly recommend the right to repair and sustainability. You can find more about it on our website, always novacustom.com. The roadmap of today, Time, he's over there, will tell you something about the right to repair. And the new laptop that's over there, the V56 series, Qubes OS certified. Wessel will then tell you something about the Intel boot card, the AC PI driver, the UEFI capsule updates, and the head firmware variants. Q3. This quarter we have joined the Right to Repair community. We have released the new V series, as I told, with Qubes OS. Last week we've obtained Qubes OS certification, and we have something to party as we now offer all the laptops with the Shadow Cobalt firmware. So that means no more proprietary firmware.
So hello everybody, my name is Stijn Veldhuis. So last month we've joined the Right to Repair community. So we are now developing new videos like tutorial videos and that kind of stuff. We will also developing new firmware updates for the next year in Q1. UEFI capsule updates, FWUPD support, Intel boot card support, the Shower ACPI driver, and as always the bug fixes. So about Right to Repair. So as I told you, last month we joined the Right to Repair community, and like to know that we are available spare parts for 7 years. You can buy that on our website. So I'm now making repair guides and repair videos, so that you, for every component of the laptop you can search on YouTube or on our website, so you can replace it yourself. Yeah, that's what I thought. So about the new model, V65, it's like a laptop, and we have a 14-inch and a 16-inch. This one is the 16-inch. It comes with 2 processors. You have the Intel Meteor Lake 5 with 125 H, and the Ultra 7 CPU. It's up to 69 gigabytes of internal memory. It's an optional NVIDIA GPU. So you can choose with or without one. So it's Qubes OS certified last week, only for the models without the NVIDIA driver. Not yet for the V45, but it's on the planning. And the heads variants come later, but we don't have an exact date for that yet. So I will show you some pictures of it. So that's in the front, and we have it right there. You can see it afterwards. And this is the 14-inch model, the V45. 54. So, Wessel.
So yeah, I'm Wessel. Intel boot card support is something that we would like to have for the next firmware update, which will be a comprehensive firmware update in our opinion. So what is Intel boot card? Intel boot card is a security feature that uses an eFuse, so that basically only the firmware that has been developed by the shower can be used on the laptop, otherwise it doesn't turn on at all. So that provides protection against rootkits, but it will also limit the user because no other firmware than the shower signed firmware can be run on the laptop, which is why we are making this feature optional. And we are even planning this with custom keys for later on, and we will like to have this ready in the first quarter of next year. So for our laptops, we would also like to have the Shower ACPI driver. which provides communication between the operating system and the firmware, so that you will get feedback from system level things like the fan speed and CPU monitor. You will also get backlight control feedback, which we used to have for the previous EC variant. With such a ECPI drive, you would also be able to set power management profiles, and you can set, for example, the battery threshold values. This would then all, of course, be possible without the need of going to the UEFI firmware settings. Then UEFI capsule updates, which is something we are working on. The goal is to update the firmware from the operating system with FWUPD without having to disable important security mechanisms. So for now, you will have to boot into the Shower tool suite environment to get the firmware updated. The problem up to now why we didn't have FWUPD support is the embedded controller, which is not updatable from FWUPD. So we have worked around this issue by flashing the EC up on first boot within Coreboot itself. So once we have that, it is the ideal situation of updating your firmware from the OS without having to disable these security features. And we would also like to have this feature for that next comprehensive firmware update. Then I would like to highlight the Coreboot plus HATS version. We currently only offer this for the NV41 series. We would also like to have it later for the V54 and V56 series as well, but there are no concrete plans on this yet. It is offered through the Shower Entry subscription, which is currently €80 a year. So what is HATS? HATS provides boot integrity verification, and it does this with measured boot, which creates cryptographic hashes for each boot component. It uses the TPM hardware to securely store and attach these hashes. And you will need a USB security device, which is the Nitro Key 3A Mini in our case. And on top of that, you could use your favorite authenticator app, which uses TOTP, for additional security verification, I must say. So this is perfect, I think, in combination with Qubes OS, which doesn't provide support yet for UEFI security, UEFI secure boot, I mean. So yeah, as always, I would like to use this opportunity to for a call to unite. So everyone be active in the community. You can report issues on GitHub. You can use our forum to discuss with other NovaCustom laptop owners, and you can chat in the Matrix room. So yeah, that's it. Thank you for your attention. I would actually like to show everyone the new laptop, so I'll do that now. Maybe it's better first to ask if there are any questions. Completely forgot that. Oh, okay, I'll show it.
Also show it to the camera. Maybe.
Yeah, okay.
All the YouTubers.
Yes.
Watching us.
So yeah, I don't know where to place it, like here?
Just in the yellow line, it will be okay.
Like this, right?
Mm-hmm. Yes, it's okay.
So let's see how fast Firefox runs. Like the Cube is not running yet, so. There we go. And it also features the Qubes OS super key. Cool. I'll show the people here.
Jeszcze Wessel,
Yes.
come on, there are some questions.
Yeah. Done.
There is a line for the questions.
Sure. Hi. I think for everybody in this room, it's pretty clear why these are amazing machines and why I would love one. But what's your best argument for normal people outside of this room and that aren't using Qubes? Why NovaCustom is much better than all of the other?
Yeah,
things
so
I see?
we provide some cool customization options for the laptop. Like you can, if you would like, you can design your own keyboard. So that's something that might be attractive for you. Also, the right to repair stuff that Tim was talking about, the sustainability aspect of that. Yeah, and of course we aim to provide some better support than usual because we offer 3 years of warranty by default, 5 years of firmware updates guaranteed, and well, these 7 years of spare parts availability.
Thanks.
Yep.
I have a couple of questions. Regarding keyboard customization, any plans for the option with track point?
No, this is not something I'm sorry for that. So for the hardware aspect, we are relying on Clevo, which is our ODM provider. They have their own designs. We do not have really influence on their designs, unfortunately. If we would like to have something like that, they say, come buy 10,000 units from us, which is not realistic for us. So that's about it, I'd say.
And I've seen some announcement about kill switches for microphone.
Yes, that's
and,
something we're still working on, which takes a little bit more time than we hoped. So we are still working on this. I do not dare to say when this will be live. So.
And one more question: smart card reader in any model? I'm not sure if Clevo support that, but
Yeah,
it's
so
something.
it's not like the same answer I have as for the trackpad. So yeah, it's not realistic for us to have such a feature, unfortunately.
Thanks.
Yep.
Does Clevo offer AMD, and do you think it's feasible to do? Like, I'm not saying about the Dasharo part. Dasharo part is our
I mean,
work,
yeah, of course.
but,
it is,
and I would say, you know, we coming to open seal era in 2026.
Yes, this is something we would really like to step in for AMD hardware, but Clevo's doing more and more with AMD, so they go in the good direction, I'd say. Still, they don't have like a model with only AMD CPU and AMD GPU or integrated GPU with, let's say, DDR5 memory.
Okay.
So once they have such a model and a decent model, because Clevo offers like a range of laptops, we always want to have the good quality standard and skip the lower standards.
Yeah, I think that's a good point, that we would like to target probably the AMD GPU, because NVIDIA is kind of arrogant right now, very arrogant.
Yeah.
I don't know if more arrogant than AMD, but we will see.
Yeah.
I have a question regarding sustainability and the lifetime of laptops. As you already presented, you were founded a couple of time ago. So the question is, do you have an experience with one of the first models of yours, how long they are used by customers, and if you could see how they are degraded over the time regarding the quality of parts and when they are replaced, or maybe which parts are the...
Yeah, I think this is something we learned about from the past. There were some models, I have to admit, that were not so good for when it comes to the quality of the case, which was also problematic for us, because sometimes it's even happened within the 3 years, which in the warranty, like in the warranty time. So this is why it was even more important to us to only have the higher quality models and no longer offer the cheaper but also cheaper in terms of the quality. So this is what we learned from that, and this is why yeah. So we are going into this direction of more sustainability, which is what we are really trying to do now with repair stuff. Now,
That's a good idea. I support it.
thank you.
I have a question regarding the Intel boot guard plans. So I think you are providing together with Dashawa for 5 years firmware support.
Yes.
Do you have some plan what you're gonna do afterwards? Given that, assuming somebody in the community would like to fix some old firmware, and with boot guard you are locked out. So do you have a plan for something like this?
I can take
What to do?
Wessel if you want. So that was already exercised with PC engines. You know PC engines?
Yeah.
So switcher and routers. Essentially, company is no longer existing. They sold quite a lot of hardware on the market. So Dashawa team just decided to do a paid version of the package. So there is the Dashawa Pro package and Enterprise package for, I don't know, like 46 euro or something like that a year. And thanks to that, we can do the releases. Of course, if the volume makes sense. If the volume doesn't make sense, then we typically kind of trying to not prolong that. Yeah. So if there will be enough people interested in continuing, that's fine. The problem is the keys for the Intel boot guard and how it will be signed. Of course, if we will have the keys, it's possible to provide that service. If we will not have the keys, so those would be, for example, NovaCustom keys or some custom keys. So I guess like if someone will choose the option of custom keys, they have to already admit that they will compile the stuff themselves. So yeah. So that's the options. That's our plan for firmware updates.
Yeah, that's also why I think it's important to make this feature optional.
Yeah.
Thanks.
Okay, that's it, I think.
Thank you.
Okay. So let's start next talk about UEFI Secure Boot implementation in Qubes OS, or maybe more about challenges and future steps. How we're planning to do this, or maybe how Marek plans to do this, because that's probably mostly on him and Frederick. So first of all, thanks to Kamil, Marek, and Andrew for reviewing this presentation and giving me some feedback. So I tried mostly. So the goal is to briefly explain what is UEFI Secure Boot and what led to all this like open source software dislike for UEFI Secure Boot. To give you better ground, because I saw a lot of FUD, a lot of weird comments regarding UEFI Secure Boot. There's like massive misunderstanding what it is, and this is part of the presentation to unroll that. On the other side, I have very strong of my personal opinion about how it should be used, which is I guess it is not exactly the same as most of the distributions, but I guess like that could be a point of discussion, and yeah. So I will try to justify that the only valid way of UEFI Secure Boot use is what Trammell defined in the Safe Boot project, which is defunct unfortunately, but it is what it is. So how the modern computer boots, just quickly. So typically at the beginning we have some root of trust, or maybe we even don't trust it, but there is beginning of the word, the anhor of whole boot process. It is typically associated with some fuses, like Wessel already mentioned, like Intel Boot Guard, or there is AMD Secure Boot. So it starts in this coprocessor, and then there are phases defined by UEFI specification. Of course, core boot got alternative phases, U-boot got alternative phases, but it's almost the same responsibility. So there is sec phase, PI phase. I will not go deep in that. There is Dixie phase, BDS, and finally we can jump to the bootloader. So it is the most important part, I guess, here is, and then after bootloader we have OS, and bootloader starting to be optional these days because of the UKI, or maybe we can say like bootloader is built into the system image. But anyway, this is like from our perspective is starting to be one binary. So this first part is typically covered by silicon vendor chain of trust technology, and this part is covered by UEFI Secure Boot. What is important to note here that this connection, this one, is not enabled by default. Even more, I will show on the next slide. The problem is that the chain of trust is not always continuous. So between Dixie and BDS, so BDS is just a Dixie module, but despite the whole infrastructure for verifying BDS is in place, and if Secure Boot is enabled, BDS should be verified. Typically in implementation it is not, because there is assumption that if something coming from flash, it's already trusted. So which maybe is not the best assumption. Of course, if the UEFI Secure Boot is not set, then there is no verification at all. So every component is boot without checking the signatures. Yeah, and of course, this is state for the reference implementation, not the state for, your favorite vendor, BIOS vendor could have different configuration. Okay. So the last thing is that, of course, you have to have full chain of trust. So you have to connect the silicon vendor chain of trust technology with UEFI Secure Boot. So typically it is called independent BIOS vendors or independent firmware vendor chain of trust, because this jump have to be somehow glued. Okay, so I guess this is important. This is a piece of the code which doing the policy check based on the image type which is executed. And on the top you can see that if image is from firmware volume, always execute. So yeah, there is no There's no check. Nothing is checked. It's essentially if firmware, if the piece of executable image coming from the firmware volume, it is like immediately executed without any signature checks. Then you can define that option ROMs. If this PCD option ROM image verification policy is defined, then it means firmware will do the signature verification of option ROMs. And Marek, just like let me know that this is very important, because if you pass the GPU into the potentially malicious VM, and this VM will be able to update the option ROM in the option ROM of the GPU, and then after the restart, this GPU will be connected to something else or even to DOM0, it can compromise the security of whole system. Yeah. But on the other side, we tried in Dasharo to enable that option, and it's happened that some GPU vendors do not provide signed option ROMs, and then you essentially ending up without graphics. Yeah, so you know we have to think what we're doing, and think who's compatible, and yeah. So let's go with the policies. Then we have image from removable media. So if this PCD is defined, then whatever you put on USB or external like a storage or SD card will be verified, and then fixed media, those are the media which are connected inside your computer, so like a disk or NVMe or something like that. And default is security violation. Yeah, those are possible other states. So you can have a policy always execute, never execute. You can have allow execute on security violation. So this was, I guess, all this MSI problem that they essentially said that one. So despite it was something wrong with the signature, they executed. Defer execute on security violation. So I'm not sure how this works precisely. Maybe we can talk with Michał after, because like I don't want to give you wrong answer. And query user is just like a pop-up in BIOS, if you can say so, that there is security violation, and just like what I should do. Should I continue or should I stop? Okay. Why I even show you this slide? How is this related to Qubes OS? It's not related to Qubes OS, but I want you to understand that the correct configuration of UEFI Secure Boot is not enough to protect your platform. There is like assumption from Linux kernel community or from many players in open source security that UEFI Secure Boot, if this will be correctly handled in shim, with SBATs, with all that stuff, we are already good. No, we are not good. We are just like shifting the responsibility to someone else, and this someone else proven many times that they cannot deliver maybe the best quality. So root of trust have to be in place and chain of trust have to work, so UEFI Secure Boot can do its work. So to be more bold with that statement, UEFI Secure Boot is the chain of trust technology, but the last part, which doing the transition between firmware world and bootloader, hypervisor, operating system world. So it's just the last part of the equation, not the panacea. Okay, something about keys and how keys work in UEFI Secure Boot. Also, I don't want to go too deep with that. But the point is that to understand vulnerabilities, which I will present in next slide, so you understand what really meant the boot hole, the PK fail, all this stuff, because this is also FAT. Like UEFI Secure is broken. It's not true. It's the broken was configuration and keys and various other stuff. But anyway, so the structure of the keys in UEFI Secure Boot look like that. There is a platform key, so PK, which allows update key exchange key, which is this KEK stuff, and then KEK stuff, key exchange key, allow to update the DB, which is database of allowed signatures, allowed hashes, allowed public keys. DBX is a database which feels denied one. So you put the hash there or the the hash of the X508 certificate there, and in that way so UEFI Secure Boot, if sees that, then already say this is security violation if anything is in DBX. DBT and DBR are like more complex databases because DBT is for time verification, because if the certificate expires, then you need that database. But the problem is, of course, you need some genuine source of time, and that's another problem. And let's not go that way. And there is like this recovery database. I don't remember exactly what's the reason for that, but that's maybe not most important for our discussion here. Yeah. So what's really was the problem? Yeah, So everything started with the fact that Microsoft became a holder of the UEFI CA key, and this UEFI CA, where it lands is there is information here in the third bullet point. So Microsoft provides certification to those who will comply, to those OEMs who will comply with given requirements, and those requirements are that their PK key certifies Microsoft key exchange key, and they put just like Microsoft because PK allows to put the KEK into that database. So the OEM who wants to be certified have to put Microsoft KEK and two other certificates into the B, so allowed database. The one is Microsoft PCA, which signs the bootloader. Then the other is UEFI CA, which signs all the other software like Shim and like any other software that is outside of Microsoft. Yeah, and the problem was with this UEFI CA. So yeah, so the problem started with the fact that Microsoft became a holder of the UEFI CA. And why did this happen? Yeah.
Very quickly, it's also worth noting that Microsoft did not want to do this. They originally wanted the same people that do SSL and web certificates.
Yeah, so
Microsoft lobbied hard for them to do it, and they said, no, we're not getting involved in this firmware stuff.
So that's
Microsoft had to do this for their own plans to work, but they don't like being here.
Yeah. I guess we can place the microphone just so other will listen, but I will repeat that. So Andrew just saying that it's very important to underline that Microsoft didn't want to do, and they really wanted to do things in correct way. And yeah, I heard also that, and I think this is valid story. But the point was that nobody else had at that point infrastructure to hold that. And they already had infrastructure for signing drivers. So that's why it happens, because nobody else from UEFI forum could handle that. And that's it. And there's also the question about the resources and processes. So they had resources and processes in place. And that's how how we land in this weird situation, which led to what I show you on the next slide. Yeah, so I already said everything here. Yes, so PK fail. Like recent stuff, I guess like binarily reporting a lot of, they finding this in here, and there. So they are reporting a lot of that. But it's essentially, this is so stupid mistake. It's like, so many vendors were just so lazy that they use it like a default or reference implementation of AMI with some PK generated there in the code. Like AMI left that for simplification of UEFI secure boot configuration. And they just didn't generate a new one. They used the one which was shipped with the code. And everyone used that. And of course it leaked. And now everyone can use this PK to change the KEK or do everything, because PK owns everything in the platform. And that means the secure boot is compromised on those platforms. Then we have UEFI shell considered harmful. Some vendors added the UEFI shell. This is the debug code, and yeah, that's something that gives ability through tool to bypass secure boot. Yeah, so this is something that have to be also the boot hole. Boot hole is a not one vulnerability but a lot of vulnerabilities. But but it is not vulnerability in UEFI secure boot implementation or mechanism. It's a vulnerability in the code that is executed in chain of trust. So, for example, shim was signed and then shim executed grab, but the grab had multiple vulnerabilities which allow it to bypass this chain and essentially run untrusted firmware, unauthenticated operating system or whatever in the chain of booting process was there. But the problem was that shim didn't have, so Microsoft signed the shim, but shim itself didn't have a mechanism for revocation at that point. So essentially didn't know if the next thing that is booting is vulnerable or not. So this caused to the situation that it escalated to the one layer upper with the revocation. So it means that whatever Microsoft used to sign the shim is already broken because they have to revoke those, essentially revoke all the shims, yeah, which allow the run of the grab with the vulnerability. Yeah. And that was like whole mess, a lot of people involved and hundreds or thousands of hours lost because of that. And of course, what's the cure here? Let's add more. Let's add more in the same way. But I will tell you on the next slide. So, but it is very interesting. This boot hole is very interesting because suddenly we have Black Lotus and those bootkits. Which are related to Microsoft Windows. I just like copied the note from there because I don't know bootloader of Windows, but it's explanation what's happened here. That Windows boot application allow the truncate memory setting to remove blocks of memory containing persistent ranges of serialized data. In that way, it caused the secure boot bypass. But it's essentially the same mechanism which was used in grab. So essentially, the code which was in chain of trust, someone found that you can trick it to bypass. So it didn't preserve chain of trust, and in that way, it started the revocation, and of course, it was the same mess but in different ecosystem. Yeah, and it looks like sometimes the cure happened to be worse than the disease. And of course, right now we have a situation in which Microsoft trying to maintain security properties of UEFI Secure Boot on the hardware they certify, because of course this damages their brand and that's not good. And then of course this generates another requirements, like a lot of requirements, various, because they want to be as strict and really do the things correctly right now, and they tightening this signing policy, which of course create a lot of issues in open source ecosystem, because open source ecosystem is very diverse. There are various ways of booting things. There are various things of implementing things, and suddenly everyone have to comply with some very similar rules. But of course, we're not saying these rules are wrong or bad ideas, because many of these rules are probably good one. But essentially this is like we going this rabbit hole, we continue that. So we have SBAT, the Secure Boot Advanced Targeting, and it's essentially mechanism for revocation in the shim. So you essentially get the same thing like with DBX, but at the shim level, yeah. Of course, like it's work a little bit differently because it has, it's not relying on the certificates, but final result is the same, that the shim will have knowledge what it can run, what it cannot run, yeah. And of course, then the process of signing shims is very bureaucratic. It's extensive. I know Kamil already sent application on behalf of Qubes, I guess, or try it. I saw the repo prepared for that, and he's attending the calls. So yes, Kamil is on that, and yeah, so there is review repo for doing that, and every distribution or whoever wants to do that, they have to go through this review process. yeah, there is like this integration with HSM mandatory, which is of course HSM are very custom, and then you have like this, like everyone have to resolve that their own. Yeah, so my conclusion here is like this: like almost no one attacked the UEFI implementation or mechanism in BIOS itself. They attack either something in the chain further, or they just using misconfiguration. So that means that it's not that implementation is wrong, or like maybe it's wrong because maybe this X508 and then methodology is something wrong with this, or they didn't thought about all possible paths. But on the other side, this can be used in valid way. That's my point. And maybe we will get there that someone will find vulnerabilities there, because maybe those vulnerabilities that we face right now were just simpler. Okay, so let's go to Qubes. So it looks like, just to be clear, those are requirements for being signed by Microsoft, not for secure boot a la safe boot. So not for signing yourself, like cleaning up all the databases and populate it with your stuff, signing the kernel, and so on and so on. That was Trammell goal. And okay, everything seems to, maybe it started earlier, but that's the oldest kind of tracking record that I was able to find. In August 2017, Wim Verwoon from Eltan asked the question about like production-related system on the mailing list, and there was like very long discussion. It's like reading that is already interesting experience, but Marek replied like what would be needed and provided some first kind of expectations, and I guess that started. Then there was this 4371 in October 2018. There is also quite interesting discussion there. Then Trammell reported on that issue that he booted Qubes OS 4.1 with secure boot enabled leveraging unified Zen EFI. Also sent some patches which were merged. But I guess this was not everything because of the requirements. But initial concerns, I guess, from Marek was that Zen EFI reliability while loading from different from different medium, from different implementation of UEFI, and also how to access the files, the kernel, the initramfs, and so on. But I guess the solution is that to build everything in kind of UKI way. And other concern back then was about complexity of boot parameters and the fact that some boot parameters are maybe not exactly safe and could lead to bypass, and if we make this static, then we have problem of any debugging or adjusting the boot process. Marek requested effort for signing boot images in May 2023 in this 8206. Last year we discussed inclusion of the Qubes OS CA, but I assume that this is not the path right now. Am I correct? Last year we discussed that that we could in Dasharo include Qubes OS CA, and on Dasharo it will just boot without being signed by Microsoft. Yeah, but my question was in the issue. My question was when we will get that, and essentially this is comment open for last 12 months.
Yes, there are other stuff.
Yeah.
That are like higher on the list.
Understood. Yeah. So that's also kind of the thing that there are more important stuff coming. I know that Frederick worked on improving Qubes Builder version 2 to include PE sign for signing keys. This is this PR77 if someone is interested. And I tried to kind of take the ISO and try to modify this ISO, try to figure out if there is a way to take the ISO right now and do something with it to essentially boot with secure boot with my own keys on the platform. But Marek's told me that this is just like not good use of my time.
There is a very long object copy command you need to use to put this unified ZEFI binary.
Yeah. So
not nice.
Yeah, I have to speed up a little bit. Yes, but the current approach is to build unified Zen FE, and there's already task for that. There are some pull requests flying, and the plan is to provide the pre-built Zen FE binaries in R43. Maybe the first question would be, is it like this would be default boot method, or this would be alternative boot method, or how this would be?
I'm not sure yet.
Yeah.
But
Yeah.
We plan to provide the pre-built binary that is signed with some key, and user can do something with that, like enroll this key to a firmware, or there are some options.
Yeah. Zen. Yeah, so this is from Andrew, mostly, plus some my gathering from discussing with him. So, like these are requirements to be signed by Microsoft, not the requirements for this other scenario, for the trauma safe boot scenario. But yeah, SBOT support is needed in Zen, not present right now. NX compat. So this is like this bit of if you have executable code in your data section of the binary, and this is something that is required by SBOT to comply with. Then there is kexec leveraged inside Zen. Then there is need for integrity checking and signature checking in this kexec stuff. So yeah, yeah, I tried to discuss with Andy to understand this purgatory stuff. But essentially, the point is that some things have to be built from kexec, have to be built in Zen to move on. There is live patching feature, which have to start checking signatures. There is this stuff with the unsafe command line options. The ABI, the hypercalls ABI for checking all passed pointers. So I guess this is also some additional work which have to be done. There are some debug options like just the GDB stuff. I don't know if this is not already done, but yeah, this was also mentioned as a potential issue. So all these things, it's a lot, have to be.
No, GDB stuff's fine. We deleted it earlier this year.
Oh, okay.
Completely unrelated reasons.
Yeah. So yeah, okay. So anyway, so the last one is done. Yeah.
We deleted it for a speculation safety to fix a speculation bug.
Okay.
That's not what I wrote on the commit in public.
Yeah, yeah. So unsigned code can't make any unaudited read writes, and that's the rule of all those technical jargon here. Yeah, and not everything affects Qubes, but the fact is that the one who will put together this binary have to ensure that the DOM0 will have lockdown mode, just to make sure that it will preserve the security properties. So what we can do right now, we can choose hardware which gives ability to easily bypass things or kind of trust something quick and fast, like HP and Acer BIOS implement ability to trust this binary, or trust this binary for next booting or whatever. Not ideal, but could be implemented, this kind of approach in the Sharo. Maybe the question is to the Qubes OS team, like what kind of issues you see with that. If not, if this is not good path, or we will get other paths working earlier, then great. We can wait for R43. Marek don't know when there will be release date, so you can just wait and be patient. You can try to compile unified kernel, like Trammell did, and you can disable UEFI secure boot, of course. And even if we will do this, it would not be end, because we don't know if we have this system, let's say this HP system or this Acer system, we don't know what capabilities we may have in this system. We don't audit the BIOS, so we don't know where those keys leaked or whatever they have there. There's also UEFI specification on which UEFI implementation can have some issues. There's no easy way to check what UEFI specification you comply to in your firmware. And every implementation may do things a little bit different. So I guess like use open source firmware, because otherwise you don't know what they put there. And how you can verify those three things? You can just try, test, have like extensive validation suite to realize if this is good. Yeah, or trust version compliance. Yeah, and I think that on hackathon I will try something of that, like a cubes builder and trying this unified image, and that's it from my side. Thank you.
It's good. It's not a question, just comments about building unified kernel image. So I've made some pull requests indeed in Builder v2. It's a matter of adding some an RPC service, but it's mostly building some component that will be able to sign the UK image. So I've recently improved documentation. I think like maybe 1 month ago, 2 months ago. So
yeah, I saw that. I tried to analyze that, but
good
didn't.
idea.
Yeah, I see that I already had too much slides. If I will try to add even more technical stuff here, it probably will not fit in. But I looked into that. Of course, my main problem, as it was 2 years ago, is Qubes Builder. I'm not essentially, like I have Qubes, so I hope that during hackathon, maybe you can help me, or just to start with that. And I would like, my goal would be to run in QEMU the unified kernel and see if with let's say, I don't know, do RSA 8K signing, and we will see if this will run.
Yes, exactly. And I've tested on the Threadripper platform also. I was having several issues with that platform, but it worked. So even with some
which platform?
Threadripper, AMD Threadripper platform.
Okay.
Known to have some several issues with E820 mapping, something like that. And I tested this unified build. It worked.
Okay. So but with enabled secure boot?
I know, not at all, but the payload works.
Okay. You're saying just like it's booting. Okay, that's fine. So we will check without signature check in QEMU if this works. If it works, then we will enable secure boot and see what's going on. Hi.
If I understand correctly, the whole chain of trust originates basically in the Intel ME, and that's still proprietary firmware, isn't it? So is there no way around trusting the silicon vendor, or what is your stance on that?
No, I guess you don't have better way right now. It's going even in worse direction, because without ME you will not have sleep states, modern sleep states. So it's like I think sooner or later we'll end up in situation that cleaning up ME will render unfunctional device. So I think this is the case for the most modern laptops that will come, and most modern like hardware like we have like on Meteor Lake based, or maybe it's even Raptor Lake also. So that's the problem. And yeah, but you know, Intel BootGuard from the mechanism side was not bad in that term that really nobody broke the Intel BootGuard by itself. They broke the configuration, the same what I said with the UEFI Secure Boot. So this mechanism was broken. Of course, like if you don't like proprietary implementation, then nothing will justify that. Yeah, but I'm saying on x86 hardware you don't have much choice. That's it. Yeah. So we can talk about that more, because that's a long topic, and.
All right. Thanks.
Yeah.
Last question. Okay. So I guess my question is, will we have time for design session to continue questions on the topic?
It's possible. I don't know, like if we still do not have confirmation from the virtual speaker from Kenneth.
Yes.
So if Kenneth will not show up, we can have design session about UEFI Secure Boot. Okay, thank you very much.
and you are live.
Welcome. This talk will be about GPU passthrough and playing video game in Qube operating system. About myself, I am using Qube for around 5 years and playing video game on it for the same amount of times. I am using it for everything, playing game, running server, reverse engineering, and offensive security. Why do I want to play game on Qube OS? I don't want to buy multiple very expensive computers for multiple use cases. I want to have one computer using Qube OS as my only operating system and be able to do everything I want to do on it. Before we start the main course, a quick reminder of the name and acronym we will be using in this presentation. Xen, a hypervisor, something that can create virtual machine. DOM0, the Xen administration virtual machine used to send order to Xen. DOMU, a virtual machine that is not DOM0. HVM, a type of virtual machine. PCI, a way of connecting hardware to a motherboard. And finally, Xorg, software responsible for display for Linux. So what is GPU passthrough? The basic idea is that Xen access to the hardware, in your case, the graphical card. And we want to configure Qube so that Xen assigns the graphical card to a virtual machine. So that only this virtual machine will be able to use the graphical card. So now that we have the basic down, we can move to the summary of this presentation. First of all, we are going to talk about the evolution of the difficulty of configuring this GPU passthrough. Next, we will look at 2 bugs that have affected this graphical card assignment. And in the end, we are going to revisit the wish that the user deploy had and how easy to use GPU passthrough can be. For the last 5 years, I maintain a guide that explains what you need to do to properly configure GPU passthrough to play video games. First of all, we were able to solve a bug in Xen. Solving this bug allowed us to delete a whole section of the guide. This section was the hardest part of the guide and required voodoo magic that no one actually understood. We also found a simpler way to have a working audio in a gaming virtual machine. No need to configure Xorg anymore, and we went from multiple pages of documentation to 5 lines of code. Also, NVIDIA modified its view on virtual machine. Before, NVIDIA wanted people to buy professional card to be able to use it in a virtual machine. So the NVIDIA driver checked it was running in the virtual machine, and if it was the case, it killed itself. So that's not the case anymore. So let's start to dive into the first bug. 2 conditions for the virtual machine to crash. First, assign more than 2 GB of memory. And last, configure GPU passthrough for this virtual machine. Back in 2018, the user Al Creator found a workaround to be able to assign as much memory we wanted without crashing the virtual machine. It was about configuring the parameter max RAM below 4 GB. To simplify things as much as possible, the address space of a system is composed of multiple things. Random access memory is one of those components, and a way to communicate with the GPU is another one of those components. So that's how we understood it. If the other thing plus random access memory plus PCI was smaller than what we can store in a 32-byte address space, it worked. If the other thing plus random access memory plus PCI was bigger than what we can store in a 32-byte address space, it crashed. So we use the parameter max RAM below 4 GB to tell the system how much random access memory it can try to fit in the 32-byte address space before assigning the remaining random access memory into the 64-byte address space. The workaround actually worked only with a very specific value of 3.5. For example, 3.4 didn't work and 3.6 didn't work either. The very specific value that you need to use is in fact either 3.5 or 2, or maybe other possible value depending on BIOS configuration. So we have to go deeper to understand what is going on. Back in 2022, the user Mati sent a patch to try to fix this issue. When I started to try to understand the issue, I got very interested in a code comment in this patch, as we see in this slide. The HVM loader is trashing the guest memory. So let's see the Xen source code about this HVM loader fix. We see a parameter used to configure if we should allow memory relocation. What we call QEMU traditional is a fork of QEMU that has been used by Xen. It is decade old and not maintained. QEMU Xen is a modern and maintained way of using QEMU in Xen. Qubes OS use QEMU Xen. And here we have the description of our bug. There is a difference in functionality between QEMU traditional and QEMU Xen. QEMU Xen is not able to relocate memory properly. So this is my understanding of the issue. When Xen is sending two blocks of memory that overlaps to QEMU traditional moves what is required to have a working guest memory. However, QEMU Xen is not able to do that. It just trashes the guest memory with a big splash sound when the two blocks of memory collide. So the solution is to be sure that the Xen parameter allow memory relocate is set to false. So Xen don't give two overlapping memory blocks to QEMU. The patch that solves this issue is on this slide. The parameter allow memory relocate should have been set to false from the start, but the code paths have been missed. So this patch fixes the issue by setting this parameter to false. So now let's dive into the next bug. At some point in time, the NVIDIA driver stopped working. This was the kind of error message we got on Linux. And on Windows, we got a blue screen of death. After searching what triggered this behavior, we found it was this patch files. I was not able to find a bug in it, so I guessed that NVIDIA driver tried to do illegal specific calls that are now blocked. So let's try to patch the NVIDIA driver, starting with Linux. Something interesting, after applying the patch files, the driver NVIDIA crash, but the driver NVIDIA open doesn't crash. I decided to try to compare those two drivers. The official installer from NVIDIA contains those two drivers. Basically, each driver has a blob that is a core. Basically, each driver has a blob that is a driver core and a build chain to add a layer of communication with the kernel. So we have binary blobs, some makefile, and some C source code. Let's investigate the difference between the two drivers and how to add as much log as possible to understand what is going on. In the NVIDIA blob, all the functions have been renamed to the kind of garbage we see on this slide. But in the NVIDIA open blob, we have the original function name at the top of this slide. So I decided to try to compare those two blobs to rename the garbage name of the NVIDIA driver to the correct name from the NVIDIA open driver. And we repeated the same kind of operation for as much function as we can. Then I try to add as many logs as possible everywhere. I modified the make files, the NVIDIA source code, the NVIDIA binary blob, and the compilation chain. And I also added new prints in the NVIDIA source code, as we can see on this slide. After quite some time, I ended up with this difference between the NVIDIA driver at the top and the NVIDIA Open driver at the bottom. We see a 4-byte write done at the offset 4 by the NVIDIA driver. It is corresponding to a 2-byte write to the command field and a 2-byte write to the statue field. However, the statue field is a read-only field. The driver should never try to write to a read-only field. So we just found a bug in the NVIDIA driver. It tried to write a read-only field. So let's patch the driver to forbid this call. We do that by modifying the NVIDIA source code to forbid any 4-byte write starting at offset 4. And using this patch, the NVIDIA driver now works correctly on Linux. So let's try to do the same thing for Windows. I tried to do that, but sadly it didn't work. So I needed to debug it more to understand what was going on. So we are going to need to go to the hardware abstraction layer. That is the thing that communicate with the GPU. So we are interested in everything that we either call all set bus data or all get bus data. That is the two main functions that will be used to communicate with the GPU. Using WinDBG, we determine that the driver crash before any call to set bus data. So we are only interested in get bus data calls. We see multiple functions that will call it with different parameters. We see a call using a double word, using a byte, using a double word at offset 0. And we will investigate more the call we will investigate the double word, the get that start at offset 0. As you can see, there is a lot of functions that are calling the function we just saw before. So the dword call at offset 0. I courageously decided to stop the static analysis part and try to find what I am looking for using WinDBG. So I decided to print the call stack of the last call to get bus data before the driver crash. That way I know the problematic call. I knew that the call to get bus data are not required since in the Linux driver it works without doing anything related to that. So I decided to patch the Windows driver by modifying the conditional jump leading to the problematic function that we call the get bus data by replacing it with an unconditional jump to avoid this call. So we replaced the assembly code jump if 0 by an unconditional jump to avoid the problematic call. I repeated this operation a second time because the driver was still crashing. And this is my final script to patch the NVIDIA driver. Applying that makes the NVIDIA driver works. So now the NVIDIA driver works on Windows and Linux. and we found at least one bug in the NVIDIA driver. So the story ends here, or maybe not. In a non-hypervised context, a write call to a read-only field should be ignored by the graphical card. In a hypervised context, a write call to a read-only field should be blocked before it reaches the hardware. So the behavior should be the same, but it is not. Does trying to write to a read-only field trigger a hidden function in the graphical card? Or maybe there is a bug somewhere else too? So let's go deeper. First, many thanks to Mamarek. I probably would have given up without his help. I tried to draw some schematics to understand how a gaming virtual machine will be able to read and write a PCI configuration. It may be not exactly true, but that's how I understood it. So this is the process to create the gaming HVM as I understand it. Xen created DOM0. From DOM0, we asked Xen to create the gaming HVM. It creates a subdomain virtual machine with a QEMU inside, and QEMU creates the gaming HVM. There is many ways to communicate with a graphical card. For this bug, we will only be interested in reading and writing the PCI configuration space. So this is how I understand the road from gaming HVM to the hardware. I simplified it a bit by removing some code to Xen to make it more readable. When we want to read or write the PCI configuration space, it starts from the NVIDIA driver in the gaming HVM. Then it goes to QEMU. QEMU will apply some logics and filter. Then the call goes to the PCI front driver of the stubdom VM. Then the call goes to the PCI back driver of DOM0. Then the call goes to Xen, and then the call goes to the hardware. So we need to dig even deeper, and we need to look at all the steps we saw before to try to understand if something is doing something it should not do. Many hours later, I was able to collect the log on this site. It is a log to a single write call. First, at the top of the slide, it's at the layer of the gaming HVM. Below, it is at the layer of QEMU, and at the bottom, it's at the layer of Xen hypervisor. Some what the fuck later, I found that those lines are very interesting. We read the value before the write. It is something that we will call alpha. We try to write the same value alpha. We reread the value. It is not. It is now a different value. I redo that. We reread the value. It is now a value different from alpha. At this point, I smelled something like integer overflow. In the middle of this slide, we can see a code that triggers an integer overflow. It is a line that defines the mask variable. I confirmed the integer overflow bug with this code. Mask 1 corresponds to the original code. Mask 2 is when I replace the emule len value by the constant 4 without giving indication on the type. And mask 3 is when I specified that the constant 1 must be a 64-byte integer. So at the top, we see the original mask variable definition from the Qubes patch. And at the bottom, the same thing, but with the integer overflow bug fixed. So with this bug and another bug I fixed in the Xen hypervisor to support high frequency processor, I modified the grand total of 3 letters of code, and it took me months to do so. So I think I invented a new unit. It's a byte of patch per week. So we just saw a bug in the NVIDIA driver and a bug in the Qubes OS code. So let's conclude the hard technical part of this presentation. Yeah, multiple times I was close to giving up. Also, something I got in my mind multiple times. If you use Xen, please contribute because it feels a bit like that. So we saw one bug in Xen, one issue in QEMU, one bug in Qube, and one bug in the NVIDIA driver. So now we'll talk a bit about the presentation from Diplo from last year. In his ideal setup slide, he wished to have a GPU passthrough ready template. I tried to contribute by creating an installation script that will create this template. The basic idea is that we download the Arch Linux template from the community template repository. Then we install the GPU driver, Xorg, support to use the kernel provided by the virtual machine instead of the kernel provided by Qubes OS, and etc. And configure everything that need to be configured, similar to the steps I described in my gaming HVM guide. The code is available here. However, I did little testing, so be careful. And I also added an option to configure DOM0, but be careful, it will not work on every setup and hardware, so please read the guide and documentation before using that. So now, let's configure our setup to play a game. We have two GPU, one integrated into in the processor, and an NVIDIA card. One keyboard, one mouse, and one screen will be dedicated to gaming. Then we configure DOM0 and install a GPU passthrough ready template. I selected I selected to pass through the NVIDIA card, and now we can just reboot the computer. We configure the BIOS to be sure to use the integrated GPU as the primary GPU. Then we start Qube and we can play a game. As a note about this video, the frame rate I have is around 40 to 60 frames per second. I say that because I know that when I try to do this presentation over network and GT, it will probably be laggy for you. But I wait a 5 seconds to so the video end, and we go to the next slide. It was supposed to have sound, but I didn't have time to properly configure my Pulse Audio settings, so you probably don't have the sound for this video. I know it was probably laggy for you when I tried to do okay, I restart. It was probably laggy for you because of the presentation over GT and the network. But when I was running it on my computer, it was around 40 to 60 frames per second, and there was no issue. So let's go back to the wish mentioned by Diplo. He wanted to do GPU pass-through without needing to have a dedicated keyboard, mouse, and screen, just like in the setup I just showed. It can be done by using virtual GL, a solution mentioned by user Bamboo Dapen in Cube forum. The disadvantage is that the performance is a bit slower than using a dedicated screen. In this setup, nothing will be dedicated for the gaming virtual machine. Also, I needed to specifically configure the variable LD library path to be /usr/lib, because using VGL run will modify this parameter and it will not work. So you need to specifically configure this variable when you use VGL run. So in the video that you probably see, I'm launching Final Fantasy XIV using VGL run. Same, it was supposed to have some sound, but I didn't manage to configure my Pulse Audio configuration correctly. It was just to show a bit how much time it needs to start, and that there is no complicated trick that you specifically need to launch the game once you have done all the previous steps. Same thing. It's maybe a bit laggy for you, but in this game, when I'm not recording, I have around 120 frames per second. It's really no issue at all. But I know that over the presentation and with the recording, it can be shown as a bit laggy, but it is not laggy when you play. Okay, so let's go to the next part. So now that we saw all the difficulty to set up GPU pass-through, how easy can it be to use? In my family, I am usually the IT guy. So I fix things and set up things. One of my family members who have no IT skill like to play an old multiplayer games. But time to time, the game breaks itself. And it is quite hard to fix. Just reinstalling the game from scratch is usually not enough. So I spend a lot of time to try to fix it. And it breaks again and again. So at some point, I decided to try to use Qubes OS to solve this issue. So I installed Qubes OS and created 2 custom scripts in the Cube desktop. You execute the script by clicking on the corresponding icon on the desktop. One icon to launch the gaming virtual machine, one icon to delete the virtual machine and redeploy a backup in a known working state. That's why when the time comes and the game break itself, I can say just click on the repair icon and it solves the issue. This setup worked for more than 2 years now, and it requires way less of my time than the previous Windows 10 setups. So yes, GPU passthrough can be very easy to use for a non-technical person. I want to thank quite a lot of people. Marek for giving me hint and explanation about how Cube and the Xen work. Jean from the Xen project for giving me hints and explanation about how Xen work. And Qubes OS team, Qubes OS contributor, Xen team contributor, because all of this work has been done on top of other people works. And also QEMU and Linux team and many, many other. That's all for me. I see that there was some questions in the Matrix channel, but I will try to read it and to answer it. And if you have any other question, don't hesitate to type it.
Thank you, Neo Wutran, for a great presentation. We in Berlin are preparing to ask questions, but first I have a question for Demi, who is connected to us through Jitsi. Maybe Demi has a question, please ask it. And we are getting ready to ask questions from Flor in Berlin.
Okay. So thank you for a great presentation, Marek here. And yeah, I have thank you also for all the great work, and it was really nice seeing debugging, this debugging, and you solve all this problem. Just one addition to that, I looked at that later. It was a patch that I wrote with this interior overflow, and it turns out that line was not needed at all. So I removed that patch and everything worked. Yeah, but I have a question about this virtual GL. Is it actually needed? Because our GUI, XOR configuration driver inside the VM, will try to use real GPU for acceleration if it's there. So, and I think I've tried something like this without needing any extra virtual GL.
Maybe it's something recent, but last time I checked, I actually needed to use a VGL run, so virtual GL, to be able to have a GPU acceleration for the game. If it was a really recent modification in the XOR configuration, like maybe 3 weeks ago, then I didn't tested it in the meantime.
Maybe it's specific for some game or a specific game or something, because yeah, I haven't tried game. I've tried Google Earth, which without GPU renders like 1 frame per 10 seconds, and with GPU it renders like very fluently. So I don't know, maybe something else. Thanks.
Thank you.
Hi there, Diplo here. Thanks so much for all of the work. I don't know if you got the audio from the audience, but there was a lot of laughter, and I just wanted to share that. Like for me, there is like some as I was watching this, like I think at some point I decided like there was a convergence of a lot of different things. Like firstly, there was a certified hardware, which was a powerful modern desktop, and then there was some discussion in the forum about being able to run a GPU. So I just decided to combine both of them. Like I thought that I wouldn't be able to like get anything running because I mean, how many things can you combine that have little chance of actually succeeding, like all combined together, and actually did. And that was also built on top of your work. So thanks so much for that. It's not really a question, but more a description of what my experience, like going through your setups and excellent guides was. Like, I mean, I don't know too much about GPU stuff, and so it was pretty much like going blindfolded into a dungeon, trying for weekends and weekends. And I don't mean to say this in a bad manner. It was like excellent. In the end, I got something working. I didn't have any expectation of getting this working, but it was just excellent that at the end of several weekends trying all the setups, I even got like a riser card because I was plugging in the beefy GPU card so many times that I was afraid of breaking the motherboard. But yeah, it was excellent that I managed to get this working, and that's all thanks to you and all of the community members and like everybody who contributed to this. So thanks so much. And unfortunately, when I was trying to go into 4.2 land, I was having some challenges, and let's just say that the 4.1 SSD, which had all of the video editing stuff, all of the templates, was the same brand, the same model as the one for the 4.2, and I accidentally forgot to switch them. So I installed 4.2 over my 4.1 drive. So the videos are still in the making, and that's the reason why. But I'm very much looking forward to like finally being able to set this up on 4.2 and ideally having a template. So thanks so much.
Thank you. And don't hesitate to try this one. Maybe it will work. At least it worked for me. Any other question? If you have,
thank you very much.
Okay. Thank you.
Thanks everyone for being here. We're going to get started. So hi folks, I'm Rowan, this is Francisco.
Hi. And yeah, I'm known as Diplo. I'm also a forum moderator, and I've been around the summit for quite a bit, so you may have seen some of my presentations. And before joining the SecureDrop team, I was working on Danger Zone. And so, yeah, that's my path here. And yeah.
Hi, everyone. It's my first time at the Qubes Summit. I'm excited to be here, but I've been a Qubes user since 2016. I've been with the SecureDrop project at Freedom of the Press Foundation since 2019. I do a combination of software development and privacy education. And we're here to talk to you about our experience developing an application on Qubes OS. So we're going to talk a bit about our project, SecureDrop Workstation. We're going to talk a little bit about the broader concept of multi-VM applications and how our thinking on that has changed. And we'll leave time for open questions and discussion. So first of all, thank you so much for the introductions earlier yesterday, but we'll give a quick overview of Freedom of the Press Foundation. FPF is a US-based nonprofit that works on First and Fourth Amendment rights at the intersection of journalism and technology. In addition to advocacy, we do digital security education and training aimed at journalists. We also do reporting on press freedom violations in the United States. And we also develop technology that helps journalists both with security, transparency. The main project that Francisco and I currently work on is SecureDrop, which is an open source whistleblowing platform that allows sources and journalists to communicate. And so the goal of SecureDrop is provide anonymity protections for sources, at the same time provide data sovereignty for newsrooms and malware mitigation for journalists and newsrooms. So SecureDrop is in use at a number of different news organizations around the world. And in particular, the work that we've been focusing on for the last several years is SecureDrop Workstation, which is a Qubes operating system-based client for SecureDrop. So how SecureDrop Workstation works is that it is the first thing that journalists will install on a dedicated Qubes OS machine that will allow them to interact with the SecureDrop server, download, decrypt, and read and respond to submissions from sources, and do all of that while protecting themselves from potential malware, files that phone home, documents, and so on. This is a screenshot that shows you approximately what it looks like to be a journalist using SecureDrop Workstation. They're able to open files that may be potentially malicious or may have tracking beacons and so on from sources in a dedicated, disposable, non-networked environment while preserving the ability to communicate with sources over Tor. So as you can see, even just from this outline, SecureDrop Workstation already wears a number of different hats. So one thing that we do is the multi-VM management, all of the components, applications, and so on that comprise SecureDrop Workstation. But another thing that we do is manage the system, and we're a little bit opinionated about this in a way that not all multi-VM applications may be. So under the hood, we enforce strict rules about the up-to-date state of the VMs that journalists use for their work. We wrap the Qubes native updater and require fully patched VMs before the application is launched. We also make other modifications such as disabling the sleep state and requiring journalists to fully power off their laptops when they're not in use to take advantage of full disk encryption. And we also make some modifications that have more to do with usability, such as offering the ability to auto-attach a USB device to a disposable non-networked environment rather than having the journalist choose. We're excited that that may be going away soon, thanks to all of Marta's wonderful improvements with the devices widget. But as you can see, there's a lot of system management going on. There's a lot of multi-VM management going on, both provisioning, restricting permissions between VMs, and also configuring the internals of the VMs for the journalist. All of this is done for them so that there is less manual configuration needed by the user. How this works, so if this sounds familiar, we've met before. We were here in 2022, and we gave a similar presentation. But where we're at now is a little bit more evolved in our thinking and also further along in the project milestones. So in preparation for Qubes 4.2 compatibility, we made some architectural changes that we're going to talk about. And we also refined our conceptualization of what it means to deploy, maintain, and test an app like this in a robust real-world context. So we're going to talk through some of that, hopefully for the other folks who may be interested in developing multi-VM apps to kind of learn from our experiences. So to zoom out a little bit, what makes a multi-VM application? We're going to throw a couple of principles out there. The first one, probably evident from the name, is that we're leveraging different properties of different environments through which the application is deployed. For example, network versus non-networked status, different operating systems, Debian, Fedora, custom kernel in certain VMs, different levels of trusts and different numbers of applications in those different VMs. So that's kind of one obvious property. You can think of this as like split GPG, split SSH involves this framework. We also layer on top a GUI and some bootstrapping. We're also talking about a conceptual framework. So we're not just talking about running a program in different multiple VMs, but we're also talking about what is the entire development and usage lifecycle. How do we borrow from SDLC best practices in other industries, and so on. Some of the principles that were important to us in terms of delivering a Qubes native app to our users, as I mentioned, unsupervised, unerror-prone provisioning is a big hurdle for us. We do remote work with organizations. We were forced into that in the pandemic. And so walking someone through a Qubes and SecureDrop workstation installation when we can't see their screen and we don't want to is like the most fun game of charades you can possibly imagine. We also work a lot with journalists who may be new to Qubes and who may not have come to it through the path that we did. And they may not recognize, for example, some of the issues that Marta mentioned yesterday in her talk about sort of surprising footguns. And we also work with users, for example, who are not comfortable with the command line interface and just want to get around and do their job as efficiently as possible. So we have to assume a lot of this context. It's really tempting when you're developing a system like this to look at a per VM or per case basis. So for example, what do we need to manage keys? What do we need to do network routing via Tor? What do we need? And so on. And it's tempting to kind of implement things in like a tightly coupled way where the provisioning, the app and package management, the deployment, the updates are all conceptually and linked in the code as well. Because that's the user experience, right? Because the users go from one bootstrapping and installation phase and all they see is VMs are provisioned, VMs are configured, RPC policies are set, and so on. But we really wanted to decouple that. And so the things we want to decouple are laid out here. It's important to decouple the system configuration from the actual configuration of the application itself. So power settings versus configuration of our VMs. It's also important to decouple the provisioning of the Qubes, the setup, teardown, what kernel it uses, what RPC policies and permissions it has, from the actual internal configuration of the Qubes. And it's also important to decouple the need for user-specific configurations, for example, Tor hidden service authentication credentials, from the need for a persistent file system. Those two things don't have to mean one and the same. We're also working hard to standardize how Qubes communicate with each other in order to make it easier for third-party or other applications to integrate with the workstation, for example, to enable other data flows and processing for journalists down the line. And of course, as I mentioned previously, we want to handle real-world deployment cases. So the work that we're showing here is only the result of a lot of work, time, trial, and error from past and current SecureDrop team members. We're particularly appreciative of this paper, Adapting the 12-Factor Methodology for Qubes Native Multi-VM Apps by Corey Myers, who's present today. Also of the fantastic internal documentation that we've received from Deeplo, who we're very lucky to have now on the SecureDrop team, and also from a lot of other work and thinking over the years on this team.
So now let's get to the essence of what a multi-VM application is. So there is provisioning, so the creation, modification, and destruction of infrastructure. This typically happens in DOM0 or an admin VM. Then there is configuration, which is what's done at the template and the app VM cube level. So this has to do with like managing the state within the templates, within the file systems. And so this distinction helps us like lead the way into separating the various concerns of a multi-VM application. And then we also, of course, have the interlink between the various cubes, the RPC policies that make part of this multi-VM applications. So how do we all do it, right? We all provision by creating, modifying, and deleting cubes in DOM0. We all configure by installing packages and installing stuff in our regular app cubes, changing settings, changing configurations. And we all create manual RPC policies, or maybe not all. This part is not for, does not, maybe now it's all everybody because of the new Qubes global config, where it's much easier to create policies. So I guess all of us end up doing this while using Qubes. So some in the community go the salt stack approach with a great presentation yesterday by Ben, where there is provisioning done targeting DOM0. It just creates the VMs and all the settings. Then there is also configuration done with salt stack, which, as was mentioned in yesterday's presentation, spins up an intermediate admin VM, which just manages the VM which it is configuring. And this is done by using kubectl, targeting a specific template or a specific app cube. And then there is also the setting up of the QRexec policies. And that's, I guess, generally done via salt stack, like just modify a file in DOM0 to set this policy up. Now, our approach started like this, and we've been shifting away from it for reasons which we'll get into later. So we're still doing provisioning via salt stack, and this is really fast. It just changes stuff in DOM0. If there is a step of like cloning, of course that's going to take time. But just to reapply this, it's generally fast. Then the configuration, which requires starting the intermediate disposable virtual machine to configure, that's done solely for the templates that we have. And so we use salt stack to install packages. And the final part, and this is where it mainly differs, is that we're no longer using salt stack to configure specific things within regular app VMs. We're doing on-boot VM specialization. So the template is the same, but then the VMs on bootstrapping, they like bifurcate their own behavior. And lastly, we're also doing RPC policies, but except it being by salt stack, we decided to just use regular packages because we do install an RPM package in DOM0, and packages already solve the issue of like, hey, there's a new version, just update this. So now, the main thing that we learned with all of this is just because salt stack can, it doesn't mean it should. And I'll pass it over to Ro to go over what that means.
Thanks so much. So in our case, as I mentioned previously, it was really important for us to decouple provisioning from configuration in order to be able to reason about the system. And I'm going to walk you through a specific example of the hot take that we just dropped on you. So this is a look at some of the files we deleted. This is a look at our proxy and a file that was part of our custom Unix gateway. So in terms of Tor networking in SecureDrop Workstation, just to give you a little overview, we use a custom QRexec to HTTP proxy, and we have a dedicated Unix gateway VM, and that's how we route traffic specifically to SecureDrop server, restricting other kinds of traffic to pull down encrypted submissions. Previously, the hidden server credentials had to be placed both in the proxy and also in the dedicated Unix gateway VM. And because this is a user-specified value that comes at the time of provisioning the system, we would place it via salt. So we would grab the value and place it in the salt run into place. So what did that mean? If you're looking at this, that meant a couple things, right? First of all, that meant the VM needed persistence. All of them did, because we didn't want to write this values into the template. So the proxy VM and the Unix gateway had to have persistence. This also meant that the salt run was that much more time consuming, because in the case of the proxy, you'd have to boot it up, place the file in place, and shut it down. This also meant that the way to verify that this configuration file was in place was to rerun the salt state. And so that was how you would check, yeah, is the file in place and valid, rerun the salt state. And correspondingly, the way to remove this file was to create another salt state that would say, make sure we remove that file, right? And so this is an example of a change that we made. So instead of dropping a file into place, we now, inside a package, a specific configuration package, we have a systemd service that conditionally runs on boot, can either read from QubesDB in the case of the proxy. In the case of the proxy, I'll come back to that in a minute. In the case of the Unix gateway, read from QubesDB and populate this file. And this runs on boot conditionally. So in this case, we can skip putting a flat file in place entirely. in the proxy. And the benefit of this would be all of this is packaged. And updates to, for example, if we want to update the service, we just update a package. We don't have to write a new salt state and an old salt state. All of this is checked every single time the VMs boot. So in the case of the proxy, we control the code in the proxy, so we can just strictly read from QubesDB directly and not install any files in place at all. And what that means is we can now make the proxy VM disposable. So this was a big benefit to us. We really leaned into our experience with packaging. I think that part of the reason that we had initially gravitated towards doing all of this in Salt is that SecureDrop server makes use of Ansible, and so coming from kind of an Ansible frame of mind where you're going to specify everything that way, we may have had to rethink our thinking in terms of how we're going to use all the components in the workstation. But for our purposes, writing code that touches Salt code, that touches the internals of a VM, the file system, and so on, was not desirable. And so I would almost extend what Ben said yesterday in that excellent presentation about sort of prohibitive salt states, command.run being the example that Ben gave. In our case, for our purposes, file.manage, file.directory, all of that inside a VM was also kind of a prohibited category and a code smell for us as well. Very happy to talk about this over the German beverage of your choosing. So the last thing that I want to highlight here is how does all this play in with QubesDB? Thanks to the namespaced VM config part of QubesDB, which is readable by the VM, we can have a template that is shared across multiple different VMs, but write to VM config and have only the desired VM be able to read that property. And so we can also configure per VM behavior based on VM config values with all of these VMs, including disposable VMs, using a single shared template. As an aside, in our case, we actually have two templates. We have an untrusted template that has a wider scope of applications, and we have a smaller template that has a smaller trusted scope of applications, and they're used for different components in the system. But at provisioning time, if a Qube service that we have defined is enabled, there's a conditional systemd unit that checks for that service being enabled, runs, and here's how we get our on-boot provisioning. So whether or not this is like an encouraged use of Qube services is up for debate, but it works really nicely for us, and it's enabled us to make a lot more of our architecture disposable and therefore verifiable at boot time and not just at the time of provisioning. So all this is nice and well and good, and we're happy with our framework, but there's one more piece, and that's where the rubber hits the road. This is real-world deployment challenges that are not captured in what we've illustrated so far. Take it away.
So when real world comes, we figure out that there may be situations where a system is not used for quite a bit. The journalist goes on holidays, or they go on a field trip and they can't take the workstation with them. And so what happens in that situation? So we've got here at the top, we've got the salt states, then two systems where we will actually run the deployments. So this is time equals 0, so both of them have the exact same thing that was supposed to be deployed. Then, sometime later, version 2 comes around, Fedora 41 lands, and so we just say Fedora 40 is no longer, it should no longer be available, and we only want Fedora 41. So, of course, the final state in System 1 is what we expect, but System 2 was offline. After a while, version 3 comes around, and nothing really changes. We figured out that we no longer need to tell that Fedora 40 is absent. So System 1 looks as we expected. But System 2 now has a managed state. We have a template, which was not supposed to be there, and which SaltStack is no longer accounting for. This is a minor problem because, I mean, in our case, we're just talking here about templates. Sure, it takes more space. But what if this was a VM which was supposed to have been renamed and it was actually containing key material, right? This is one of the things that we have to consider, and for the time being, we just have to make sure that all of the workstation users always run all of the updates all of the time. But it's something that it seems that SaltStack can't help us solve. We have some ideas of how to troubleshoot this problem or how to make it better. But yeah, so there is the mismatch. So this is one of the ways in which configuration drift happens. And so some of the solutions are, for example, stateful provisioning. So using a provisioning tool which does account for the state which was deployed in earlier times And if there is something which is not according to what we want right now, it should be removed. Tools like Terraform or OpenTofu do this kind of thing. Unfortunately, as far as we know, Salt doesn't have this kind of functionality. Another approach would be to have a migrations, a database-inspired thing where you store all of the previous Salt states. So if the user is in version 1 and now the current version is version 3, they also go through version 2. This has the disadvantages that we need to ship all of the previous things, and we also need to make sure that all of these deployments happen, and so it just takes more time if the system hasn't been online for quite a while. And a little bit more provocatively, statelessness everywhere, the other alternative with container-styled volume management, where the data is separate from the regular app cubes. This isn't the way that Qubes works right now, and you'll probably be pretty far. But that way we could just not care about the infrastructure, just rebuild it and then reattach the volumes that have the data. And in the case of the workstation, there aren't too many components that do have data. Then the next steps that we also have, which are a little bit more concrete, are extending the architecture of the workstation. So we mentioned earlier that we wanted to be able to let newsrooms integrate into their own data processing workflows, but there are already some concrete ideas that we have, for example, integration with Signal, and also integration with Danger Zone, the other project from Freedom of the Press Foundation. And so we want to converge on a standardized RPC format for sending documents over, such that we're not creating a very custom format to send data over. And there are some other additional properties that newsrooms may want to get codified in this process. Another thing is configuration health checks. So there may be various reasons why configuration drift does happen, and so for example, for example, the configuration drift that we talked earlier could be mitigated by running health checks. Is everything according to what we expect? Even if we don't directly manage it already, just being aware that it's happening and warning the user before actually starting the workstation can already be helpful. And the other thing is, what if the user was playing around with something? We made our VMs internal recently to reduce the chance of that, but it's a free and open source system, and the ethos is not restrict the user from doing anything. But still, there may be cases where we want that for their own protection. And so we may want to add a component that does health check before starting the multi-VM application, just to make sure that everything is as we expect. And lastly, there's also the idea of using an admin VM. So Joanna, a long time ago, described a corporate VM where the user would install, and this would be just the whole thing for the corporation, but their DOM0 would be safe, and they could just also install their own personal things. In the case of the workstation, this wasn't necessarily it wasn't a necessary design choice at the beginning, because it's a dedicated machine just for this purpose. But there may be situations where, for example, with Danger Zone, if folks want to install Danger Zone, they may not want to add another repo to DOM0 just to have this multi-VM application, and the same thing may happen with other multi-VM applications. So it would be nice to have an admin VM which does manage this. There are some open problems regarding admin VMs, namely in terms of the policy management, which currently there isn't a concrete way of just making sure that it can only manage its own RPC policies or defining where the boundary is. So there still needs to be some thinking about how to do this in terms of a multi-VM architecture ideal. But for the time being, these are the next things that we're planning on working on.
Yeah, absolutely. In our case, we're never going to have journalists using a Qubes laptop for their personal and for their work purposes, but the example of SecureDrop Workstation kind of being in God mode and installing an RPM and DOM0 because we orchestrate a lot of VMs, that's fine for our purposes, but for other multi-VM apps, as you mentioned, Danger Zone, other third-party integrations, it might be nice to be able to separate the idea of can orchestrate multiple VMs from has powers in DOM0, and it's nice to pull those two things apart. So we'll wrap up with some takeaways. These are kind of our top tips for anyone who's interested in developing apps on Qubes, Qubes native apps. We encourage you to prefer packaging over orchestration whenever possible, especially for the internals of your component VMs. We really leaned into using Qubes DB for Qube-specific config values. We used and or possibly abused QVM features and systemd conditions to create environment-specific behavior, and that let us make a lot more things disposable. That was a great takeaway. And something that didn't quite make the cut, but that's related to packaging, is on our end, we used to have a lot of different component repos, and every single Debian-based VM had its own component repo. We consolidated those into a mono repo, really improved developer experience, CI, ease of managing, breaking changes that related to different VMs. And that was a big improvement for us as well. So we really want to thank everyone who's helped us with this project. The Qubes team, thank you so much for all of your time and energy. Former and current SecureDrop team members who've really contributed so much to this project and helped us get to the place that we are today. Other projects in the Qubes ecosystem that have also shaped our thinking, including some of the projects we've seen presentations on this weekend. And as well, of course, the SecureDrop Workstation pilot organizations, all the newsrooms and journalists who've trusted us, given us feedback on Qubes, given us contributions, the community contributors that we've had, and really everyone who's provided assistance along the way. So thank you all so much, and we'd love to take questions.
I have a question. If you have a wish list from the Qubes OS team, what will be the first item you will have to be available for you? For example, you speak about admin VM that is able to provision SALT, Qubes CTL. I think it should work, or at least I think for maybe some short adaptation, you can run SALT stack inside admin VM. So I think it's so. What will be your wish list?
I was going to say, I think this is a great question, and I think if you ask every member of the team, you might get a different answer. Do you want to go first?
So there is something that's already in the works and will massively help the workstation, which has to do with like the devices redesign and just like preventing the user from like attaching it to VMs where we don't want those to be attached. So that's already something that's in the works, and that would be already like amazing. And we're very much looking forward to that.
Yeah.
Yeah. But I think we can share a wish list later.
Yeah. I'm going to go out on a limb and say that what you mentioned about extensibility and what we talked about at coffee this morning would be up there on my wish list, which is like, how can we communicate information between VMs, and like, are we using RPC correctly? Is there any way to contribute more information back and forth, especially when we think about integrating things like signal and danger zone? There's a need to not just communicate a success or failure status from standard in, standard out error, but there's a need to communicate like in progress data. Like for example, so far I've streamed this many pages, there's this many to go, success and failure, in like an interlinked way. Wish list, wish list, wish list.
I'm not stealing it either.
Okay.
Thank you.
Yeah, thanks.
Thank you so much.
Thanks for a great presentation, and please do share feedback if you miss something in Qubes, because for example the VM config thing, it was really easy to implement, but from what I understand it helped your case a lot. So yeah, please do share feedback like this. The QVM service thing and conditional, it's specifically designed for this purpose. So yes, this is the right use. But as for the actual question, when you create the VM, you have this issue with removing some stale thing. Will applying the state from DOM0 and having all the VMs that are SecureDrop related have some specific tag, will that help?
Yeah, so that's what we do now. I think the question really comes to, as you mentioned in your slides, what happens in real world conditions when, for example, someone is offline for a long period of time. So the question is like, how long do we maintain logic that says Fedora 37 absent, weeks, months, years, things like that kind of add like cruft to the code over time as part of it. But yes, tagging super helps. All of those things help. Do you want to add anything?
Yeah, I think that's already like been super helpful, and like the tagging mechanism has been pretty helpful.
Yeah.
And I just wonder, like, when we have admin VMs, like the tagging will be even automatic. So
yeah, that's if you create a VM from admin, it's created by something, so it's automatically. And we have similar idea for the policy. So currently, policy can specify the source tag, something happens. There is an issue to support multiple tags, and we may combine this with includes. So we can have a policy include that is applicable only to VMs with specific tag.
Yeah,
so
I think that would be super helpful in terms of like the thinking of the concept of an admin VM and like how it interacts with other admin VMs and allowing us to define a policy of how that interaction works. Yeah. Nice. Thanks.
Yeah. So thank you for the presentation and the congratulations on the progress you made on this. My question is, when you talk about workstation, how hardware specific is this product?
Do you want to go first?
I think it's as hardware specific as Qubes is hardware specific. At least for the time being, that's more or less our situation. We want to make sure that people have devices where Qubes will run well.
Yeah, I think that's true on a theoretical level, but there's a couple of further restrictions that we make, and honestly, some of them are from a support perspective. So because of journalists working remotely and because of like already kind of the challenges with communicating about what's happening on a system where you can't see and you collect no metrics and you don't want to know, we try to restrict folks to laptops that we also have that we can also test on, and that's, you know, that subset is constrained by the size of the team. So that's one part of it. On the SecureDrop side, and also relevant to some of our VMs, here we do also package a custom kernel, and so compatibility with all those things matters, but really if it boots Qubes, the goal is that it can run SecureDrop Workstation. Additionally, it's got to be a pretty beast of a machine, like you want a lot of RAM, you want a lot of storage.
Yeah, and are there any hardware or firmware specific things that you're currently missing from the device you've been using so far?
I think the answer is yes, and come talk to us at lunch.
We're very excited to hear about all the kind of the AEM kind of progress that's being made, because that's like a big thing that we'd like to actually have in place for journalists. So that's one big thing.
So for those of you who are online, I mean, I've heard like the AEM stuff could potentially be interesting for us, and we're happy to discuss.
You'll do that. Thank you.
Thank you.
I guess I didn't catch the service part. Adding the service. So who's responsible for adding those services?
So all of this is controlled by us in our bootstrapping phase. So these are packages that are installed on the target templates. So for example, this is installed in the Unix gateway as part of a Debian package that we maintain. And so at install time, which is the entire installation, the salt run that provisions VMs, installs packages, et cetera, this is configured. So basically, in terms of a user interaction perspective, at the beginning, the user creates a configuration, which is now a file, eventually will be a GUI. The user creates a configuration and just says, let's go, and we provision everything for them.
So if I understand correctly, Salt essentially installed the RPM package which you prepared earlier.
We verify and install the RPM package manually in DOM0 right now, although that's something that we're going to improve the bootstrapping on. So once the user has verified, yes, this is a valid signed RPM, signed with our correct signing key, and it's installed, the rest of the package installation, so the Debian packages in VMs, is managed by Salt. But the RPM package is kind of like a bootstrapping orchestration package that is first installed, configures RPC policies, and then runs the actual installation live with the user.
Okay, and I guess you have to maintain these packages compatibility with given version of Debian.
Yeah, exactly. So the workstation repo, if you were to look at freedom.press/SecureDrop Workstation, that's our DOM0 RPM etc. related repo, and SecureDrop Client is the Debian compatible repo that has all the packages for all the different VMs, including the application GUI code.
Okay, now I get it. So one more comment about this restriction of modification and kind of unknown state that someone didn't do something weird. So maybe some form of attestation is needed for that, and give some signs of, like something is not exactly configured correctly here, or something is missing, or hash doesn't match the requirements.
Exactly.
Yeah.
Although I would add one of the restrictions is that we don't want to attest, at least I think the team would agree, we don't want to attest like individual person's machines. So that would have to be like a local. Yeah, it would have to be like only a local thing. Yeah, of course.
So yeah, but it's true, but also the problem with local attestation is like, suppose all of our files are properly in place, but the user had added an additional config file and dropped it in an additional directory. Yeah. How do we, you know what I mean? Like, how do we attest to that? So the closest that we can get right now is like disposable VMs configure stuff on boot and say at least when we started, we know what state it was in. And then there's the philosophical question of like, how far do you protect users from themselves? If someone's going to go and edit a config file and drop it into place manually on boot, maybe we say, good luck, have fun. Maybe we say, please don't do that. But yeah, until there's like a way of kind of locking that down, that's a bit of a cat and mouse.
Okay, we can talk about that. I will not, take the mic longer. We can talk about
Thanks
that
for your
later.
questions.
Hi, so the particular example, and maybe there are others, of the Fedora 40 becoming deprecated. I wondered if, for your use case, where actually deprecating that and removing it from the code base is pretty high risk, potentially, you can just move that to a separate file and just, instead of considering it cruft, because Salt makes that easy to do, because Terraform, you're introducing state, it's adding the complexity. You don't necessarily want to do that across all your client machines, but the Salt, I thought, in terms of cruft, it's actually fairly minor. What do you think?
I should add that in this specific context, I put there Fedora 40, just so we're using language that everybody's familiar with. In our case, we also have our own VMs, and we're only really like deleting our own things. We don't want to like delete things which are kind of like default. So I guess those still hang around.
So like it's a great point to specifically speak to the Fedora case. We insist that SecureDrop Workstation is the first thing that is installed on Qubes by the journalist, but it might not be the only thing. So for example, if a user makes their own VM based on a Fedora template and then we rename the template, we might have borked their system. And so there's kind of an interesting line between like, do we clone and maintain and modify our own templates? Probably yes. If we make use of the system templates, we have to know that we have guarantees at the time that they're installed, but then afterwards the state may diverge if the user wants to make any customizations. And so we don't want to discourage like after the fact customizations that don't interfere with our components, but we have to walk that line.
Okay. And for this case, so the Fedora 40 template would be shared with other applications, and you wouldn't take full ownership of that with SecureDrop, but you could have VMs with your own protected names that are reserved that you might want to keep ownership of indefinitely.
Exactly. Yeah, so in this case, the Fedora template's just used for sysnet and sysUSB and stuff, but yeah, exactly.
Yeah, and just to address the persistent state and like having to increase the complexity, I mean, this isn't something that we have already fully worked out. It's still in the works. But just like thinking about in terms of like the health checks of the system, like state doesn't have to be like too complex. It's just like literally like cubes.xml already has the state. So I don't think it would be like overly complex to think of a way to like understand the state that's in this multi-VM application, and if anything has diverged from what we expect it to be.
Fair enough. Thank you.
Thanks.
Thank you.
Regarding the state management, do you really? I don't think you really need to keep track of all the old state. It would be enough if you can enumerate what set of VMs are you managing. Yeah. Like if you say that the system is exclusively for SecureDrop, you can just look at all VMs and everything you don't know you remove or give a warning that it should be removed. Or if you want to have some customization options, you can add a tag to all VMs you created and then enumerate which one have this tag and are not expected. So you don't need to keep the track of all the changes you made over time.
So it's true, except in our use case, data loss could be catastrophic for journalists, especially if we're saying this is a system where the server and the workstation are the source of truth. Journalists get real mad if you delete any data that they might want. And so you're right in the sense of like if we were saying this is a solely SecureDrop Workstation appliance and the only thing you are expected to have on here is RVMs, then yes, that would be true. But in some cases, there's power users who are excited about Qubes who say, I want SecureDrop Workstation. Oh, and I also have this other cool thing that I want, right? And so it's kind of a negotiation between, are we truly taking over the system and restricting other things, or are we saying, here's our part that we've bootstrapped, we're confident in it, the rest is yours to play with. And I think there is so much desire to use more features of Qubes that there are other VMs on the system as well.
Yeah, I mean, you don't have to just remove it. You can just have a warning. There are this and this VM we don't know about, and it's then the job of the admin to assess. Yes. And I think that might be also something which could be extended for the salt rules, that you have some rule which not only specify how to create a VM, but actually specify the set of expected. And when there's some difference, it gives a warning or actually removes stuff.
Yeah,
totally. I like that.
Yeah, and I think the idea of QVM tags, which we're already using, really helps us do that. It's a little bit different on the like the two different hats of the workstation that we mentioned at the beginning. We can definitely do that for the workstation managed multi-VM applications, because like there we have like an architecture that we're supposed to be the ones in control.
Mm-hmm. The idea of health checks like that is a really appealing thing to us. This is an open source project, github.com/freedomofpress.
Nice.
Yeah, so for the this updates, the approach for migration, I think it should be also quite easy to implement in Salt, because I think you can access QVM features in using Pillar, I think. So you can have a feature with a generation number and have some conditional. If a generation number lower than this, then apply this. And you can separate in a separate file to not clutter your main file. So that should be possible, I think. But one more question about the VM config features you use. You use it to also store some secrets that do provision inside the VM. Are you concerned about the accessing those features? Because any process running inside VM can read.
Yeah. So we don't use it to store secret keys. The most secret thing is the Tor authenticated hidden service, which, because the proxy VM only runs our code and only runs that service, and because the Unix gateway is dedicated to our purposes, yes, we're concerned about it, and we limit it. We limit the capabilities of that VM for those purposes. Anything to add? Mm-hmm.
Yeah, there were some questions from chat, and people poking me that we're not asking
sorry, chat.
questions from chat. So sorry for ignoring you, but I'm fixing myself. Is there a requirement to launch a set of app VMs in response to user two-factor authentication?
So right now, the two-factor auth would be the authentication with the SecureDrop server, and that happens just in one VM, the main client GUI VM.
Oh, yeah. So the next one is about GUI VM, yeah, from Demi. Would GUI VM be useful? What about attesting to the SecureDrop server, but you already thought about attestation?
So yeah, so we're not using sysGUI, but we are using our specific VM SD app just contains the SD app or the SecureDrop application GUI code. And yes, it might be useful. We haven't looked into it. So that could be something we look into in the future.
And one more question. Does Qubes support multiple management VMs servers? I don't know, maybe this is more for Qubes team, or I don't know if you can answer that.
Like the multiple management? I think, was that what you were saying about wishing for finer grained permissions on admin VMs?
Oh yeah, I do. Yeah, not sure what they mean by the but I assume they're talking about admin VMs.
Yeah,
so if that's
I'm
the case.
not sure about the specific question, but I think the answer is yes.
Yeah,
Mark
the
said
answer
is
yes, but there is no isolation between them right now.
Mm-hmm.
Okay, I guess that's all the question from the chat.
Cool, thank you so much.
Yeah, thanks a lot.
prawa moderatora mam przydzielone.
Przełączyłem.
Ty, prawa moderatora, jeszcze nie. Okay. Ja jeszcze nie chciałem tu już być przyłączał, ale dobra. Jak już to zrobiłeś, to... Dobra, to byś po prostu, jak już jest, nagrywa się, tak, jakby na streama, to na razie jest włączony mikrofon, wszystkie są wyłączone mikrofony i sala, rozumiem, nic nie. Tak, nic nie.
Raz, próba mikrofonu. Raz. Halo.
Teraz idzie pytanie z sali, za mocno otworzyłem tłumik, okej. Teraz idzie pytanie z sali, a teraz odpowiadasz.
Teraz cię dobrze słyszałem. Teraz to jest odpowiedź. Raz. 1, 2, 3. Czy mnie dobrze słychać?
Wracamy. Raz, dwa, trzy.
Raz, dwa, trzy. Ja ciebie słyszę dobrze.
Staszek, chodź tutaj, zrobimy tranzycję.
Raz. Jak mnie słychać? Raz. Próba mikrofonu. Raz.
W sali słyszymy bardzo dobrze, a ty jak nas słyszysz?
Ciebie też słyszę dobrze.
Przy czym jak za mocno tłumik otworzę, to bardzo skrzeczę tam u ciebie, słyszę.
Tak,
Czy dobrze jest?
mocno teraz trochę.
Jakość dźwięku jest?
Troszkę skrzeczysz.
Dobrze, więc ja przytłumię trochę ten mikrofon.
Ewentualnie teraz jak jest?
Teraz jak jest?
Teraz jest lepiej, zdecydowanie.
Zdecydowanie lepiej, okej. To jeszcze ściszę w Jitsi mikrofon. mamy tutaj. Raz, dwa, trzy. Jeszcze nie. Jakim cudem słychać? Tu jest. Okej, teraz włączyłem na stream. Zastanawiam się, jak mocno mnie słychać.
No,
Bo
cicho w miarę,
do
ale
końca.
słychać.
Nie usłyszałem, w jakiej jakości słychać.
Dobrze cię słychać teraz.
Dobrze czy bardzo dobrze?
Dobrze, czysty dźwięk.
Dobrze, to teraz jeszcze mocniej otworzę, jak jest teraz.
No jest okej.
Okej, czyli teraz sprawdzimy, w jakiej jakości to się nagrało.
Mhm. A tu coś może. Raz.
Raz, dwa, trzy, raz. Telefonu. Raz, dwa, trzy, raz. Wyjście mi otworu.
Raz, próba mikrofonu. Raz.
Zadaję pytanie 712.
Cicho, coś cię słyszę.
Teraz zadałem pytanie.
Nie słyszę cię
712.
za bardzo, głośniej trochę.
712, zadaję pytanie.
Bardzo cicho cię słyszę.
Raz, dwa, trzy. Raz, dwa,
No
trzy,
słyszę cię, nie jakoś bardzo głośno, ale słyszę.
Zadaję pytanie.
Ale muszę telefon do ucha przyłożyć praktycznie.
Dobra, wracaj do mnie. Staszek, a nie masz ściszonego telefonu?
Nie wiem, ja nie wybrałem nic. Nie jest na pół.
Na pół to jest włączony, nie można powiedzieć złączonym, czekaj. Który mikrofon jest włączony? Nie jest Teraz nie możemy sprzęgać. Nadal sprzęgał. Raz, dwa, trzy, raz. Masz wyłączone wszystkie te inne, jakbyś zobaczył. Wszystkie są wyciszone. Dobra, tylko ten jest. Okej, teraz pytanie testowe 718.
Strasznie głośno jesteś teraz. Halo?
Znowu pytanie testowe.
Teraz jest lepiej.
218 zadaje kolejne pytanie.
Teraz jest dobrze.
I jeszcze kolejne pytanie 1084.
Raz. Próba mikrofonu.
Dziękuję, koniec testu.
Good, hi. Then let me start. So I'm Jan from NitroKey. I'm not having prepared a whole presentation just to present to you. Instead, this is just a discussion I want to initiate and just give some introduction to this discussion I hope to have here with you. So it's about heads. You know, heads is a firmware mostly developed by Thierry, and the presentation stopped working here. Here we go. Okay. So in a nutshell, heads is a specific firmware to mitigate evil mate attacks through measured boot mechanisms, which relies on a USB key, like a physical USB key, like from NitroKey, as a root of trust. So when you boot up your system, the integrity of the installed firmware in the computer as well as the operating system essentially is then measured by utilizing the NitroKey as a root of trust. So this is kind of unique security feature only heads provides so far. And it's often combined with Qubes OS, since both, target high security environments, so that's a good fit. And this is why we also pre-install it on our Nitro pads. And technically, just very high level, it's core boot based with a Linux payload where this security feature is implemented. And then this boots an operating system like Qubes or another one, a Linux based one. And we love heads. But now we ship it also since a couple of years, and we have learned some lessons. And this is what I want to discuss here with you, if we can do better. So, and one of the main concerns and complaints of our users is that this entire measurement needs to be executed again, and there's of course a re-signing involved when the kernel is updated. And many users don't understand this, and in fact if you compare it to ordinary PC users, this is in fact complicated. I can understand this. And maybe not so far for this crowd here. I think most of them are very technical, but so for ordinary users. And this is a burden in order to make heads more popular and get more users on heads. And some even want to use it for Windows. Not so many private users, but more enterprises. There are in fact some enterprises, of course, using heads, but then as it requires now a Linux-based system, they combine it then with, say, Ubuntu or Qubes. But many enterprises would like to use this then with Windows. And that's not possible because of the K-exec mechanism used here. In general, usability, I think, improved a lot over the years, but there is still room for improvement, at least from our customer support perspective. There's still a lot of questions from the users, so things could maybe generally be improved. Of course, we would love to see more hardware, being able to boot heads, to use it with heads. And since there's essentially one main developer, one main maintainer these days, I would like to see Thierry more happy, and I think now he has a lot of work to doing with maintaining the system. And so we were digesting this idea for a long time, and this is what I would like to discuss with you. And it's essentially about, hey, can this measured boot feature, which is now unique to heads, be integrated into Tiano Core as a maybe considered like a next generation heads, so that essentially you have this security feature in Tiano Core, which then would allow users to configure it as some other options you typically can configure from UEFI-based BIOSes and from Tiano Core. Since it's UEFI-based, it would allow to start Windows. And it already has some secure boot mechanisms. So if then this measured boot mechanism, which we have in heads, which relies on the NitroKey as a root of trust, if this could maybe combined with, say, the signature key of the Qubes operating system or of another dedicated Linux operating system, or maybe even in general of a Microsoft signing key. So if this can somehow be combined to allow kernel upgrades without re-signing. I think from the Dachau perspective, which now has essentially two flavors, one UEFI base, one heads base, this would also unify the code base. Maybe makes development faster because hopefully maintenance would be easier with a single code base so that development resources can work more on adding new features, improving the usability. It would perhaps make it easier to get more hardware supported and hopefully in general reduce the maintenance and efforts of this. So that's a discussion I would like to have with you. So, which I'm opening now. So, what are your thoughts?
I would go, but like Marek, come.
Yes, please come to the stage.
I just want. Can I? Yeah.
You can use that mic also.
I can.
Okay. I will just restate the facts so that we start like the discussion like at the same point. Like when we talk about like a root of trust being in the USB nitro key, the actual root of trust is actually in the boot block. The measured boot is starting from there. The boot block measures itself, Sorry, I will restart. So the USB nitro key is actually the attestation part, but it's not the root of trust. The root of trust is inside of core boot, measured boot, which starts at the boot block, which measures itself and then measures all the other stage of core boot. And at the end of it all, like it actually has its own tools inside of it to be able to use the extended measurements that were done in the TPM to actually create a sealed secret that was already sealed, and unseals that secret, authenticates with the USB dongle to make sure that it's still in the same state as before. This is just the result of core boot, measure boot, and after that, EDS takes its own subset of measurements to report and extend in other banks of PCRs, and that permits to seal another secret, which will unseal the disk unlock key with a passphrase. So that's just that part.
So can we say that essentially nitro key attests somehow attests?
Yeah.
Yeah. Local attestation server.
Yeah, like basically yes. So the key is actually an attestation server.
But it essentially attests what was stored inside TPM.
Yeah.
Not the measurements.
Yeah, so the boot block situation in this case is not great.
Yeah.
So my question would be, isn't it better to use DRTM? Because you don't have this boot block problem there.
It would, but then again, like it requires other blobs, and that's where like it's always the same. I don't have a clear answer on that, but yes, it would be nice. But like going there, we talked a little bit like of this conversation, and for EDS to be able to work in that way, since we don't rely on grub, which you do, would mean like key exec.
Do you actually need a grub? It's like we currently.
I think this kind of diverts from this topic,
sorry.
doesn't it?
By yes and no, because like if we want to merge, let's say in Tiana Core, or it's either we continue and we merge inside of EDS, or then we get outside. That's the mind game we're playing in this talk right now. So let's remove EDS or merge efforts inside of EDS. How do we get one thing that do both, use measured boot, and you will be the maintainer of this discussion, like if we go off track, I think. But like from my perspective, that's it. So yes, the RTM would be nice, but then inside of EDS that requires key exec.
Yeah, and
that where you could jump from what you know, because we discussed this like on the dinner today.
Yeah, I don't know if this is a good segue. Because if let's go to the slide with the with the concept, not this one.
Next one.
So the first problem I see, what would be the feature parity with heads? Because I think theory assumes that there have to be Linux kernel there, so that's essentially neglect the UEFI. If not, then mimicking all the features that heads already have inside UEFI is a big problem, because first of all, PGP. you have to port PGP to UEFI.
Doesn't need to be PGP, I think. Like I would say it's implementation detail. Like
So
currently
that's what my
PGP,
that's my question. That's my question. What kind of feature parity we should achieve?
Yeah, that's kind of what I have in my head as well.
Yeah, I don't think in this approach you need to like match heads exactly, like just replace firmware and it's compatible with the same boot part. I don't think that's realistic. So if there is something that would make it nicer, and also GNU-PG as an implementation of the standard is not currently the preferred one, I would say. So there are, we have some alternatives now. So yeah, I don't think we should focus to keep it like heads, but
that is very important kind of segue because we were inquired about the use of Open PGP CA project of NLNet inside UEFI. So, but when I asked this to Christian and Sergey, they kind of suggest me that I'm crazy, and that's not easy thing because then you have even Sequoia Rust stuff to integrate in UEFI is kind of already going into area of quite expensive project.
It's not easy, definitely.
Yeah.
Yeah.
But I think the angle there would be also. You correct me, but like the goal would still be to use the security dongle to do operation, which is an open PGP card, meaning we have to respect that standard. As of now, there's 2 dongles for HOTP.
You have token which support different things.
So I think there could be different potential solutions being considered. So OpenPGP card is a standard currently used, but it's a device standard, so kind of interface of the device. It doesn't necessarily mean you need to use OpenPGP or GNU-PG. You can just use a plain RSA signatures and decryptions and keys for whatever your own format, if you like to, or something entirely different, maybe even FIDO, if you make use of.
And I think you
that.
also support Nitro key specifically supports also X509 signatures or something like that. It's the different tablet on the token.
PIV, I
yeah,
guess.
exactly.
Yeah, you can use X509 with PIV interface and OpenPGP card interface as well. It's not that popular, but it's possible.
Yeah, it doesn't need to be PGP.
Okay, but let's try not to go too much into detail, I would say, because there's 15 minutes left or so.
Oh, right.
So, yes, this was now about efforts. Yes, it is not, it would not be a simple effort, a simple project. There would be tools to be integrated, whatever tools, whether it's Sequoia or GNU-PG or maybe something smaller. There are already some cryptographic mechanisms available, so it might be, some of them might be useful here as well.
So,
and beside of the efforts, so do you see any roadblocks of this in general?
I think it's very interesting use case if you connect this with bootguard. So you protect also the boot block, like with bootguard, and then you have kind of more open UEFI secure boot, I would say. Because UEFI secure boot is tied to specific keys you need to it's forcing some specific key hierarchy on you. But here you can be more flexible. You can support user's key for different things and not everything with the same key. Yeah, I think it may be interesting case for.
Yeah, I'm trying to think about that and how is this different from UEFI secure boot or just adding to UEFI two-factor authentication with the token.
Well, UEFI secure boot itself, it assumes your firmware is in a good
But you
shape.
can provision it.
You can provision it with your own keys, but still the thing that verifies if the signature is good on your bootloader or
Okay, so
kernel
you mean
is-
delegation to USB
yeah.
token? Okay.
Yeah, and here we still rely on boot block being not compromised.
So,
which
so
can
we're saying
solve with
about
boot block.
sorry. So we're saying about UEFI secure boot with delegation of the signature verification to the
Or actually attestation with attestation of the thing that verifies signature if it's still in good shape. So you have external verification if the whole firmware that later will verify your signature is still in good shape.
Understood.
Yeah. So it's a bit stronger, I think, maybe.
I just want to go back like to this point, like defining. That's something that I
Yes.
challenged you a couple of times before, like this problem, the first one. So, kernel updates without resigning. What's your take? Like how can, because that's the main issue for end users, that's for
Yes.
sure. But like without trying to change everything, like I'm not addressing the second point here, like UEFI would need to, or otherwise we need shimming and everything that oh my god, I don't know, like inside of it right now, but like the kernel updates without resigning. So
Yeah, so for that we the distribution, pick some distribution of choice, would need to ship kernel binaries with some kind of signature. It could be detached signature or it could be UEFI secure boot signature, some kind of signature on. We will have this with work on secure boot anyway. Maybe we could also ship detached signature for all the binaries, so we don't run into some of the secure boot problems. But it's a bit complicated in with the way we currently build packages, because we first build everything, including and package this into RPM, and this environment intentionally doesn't have access to any signing keys. Signing is done later, but you have all the
after the fact.
Yeah. So it would need to unpack, to sign and pack again or something. It's a bit complicated. So we can think about how to schedule that work and like prioritize and maybe get some funding to rework some of this, but it's not a simple change.
Yeah. Because to me, like it goes back to DK exec point that I was having before. If I follow the discussion, we're going in the path of UKI. So if this is the case, then your main problem, if I understand correctly, would kind of disappear in one rock, two stone. And if the key exec work, more discussion, we're not going to fix this today, but like if key exec was able to verify the signature, because key exec is supposed to be able to do that.
In Linux, yes. In Zen, not yet.
Okay, so it's another problem. Okay.
But you have Linux as a payload, so it should work.
Yeah. So we would be able to verify if the binaries are signed and we already know the signature. Basically, the first problem would disappear if the work was done.
Yes.
And then the RTM question mark.
Is this updates? Do you want to get this on the attestation side or just what the firmware loads?
I can try to do it like in 15 seconds, but like the attestation of the firmware is one part, communicates with the key, says it's good. After that, like the verification of everything else being, runtime is validated to unseal the secret. Once that is done, the verification of your default boot is verifying the content of what was signed by the user key inside of /boot. So that's the part that we're talking about here, because if you install updates, you reboot, then the kernel initRD xen grub configuration will change. The user is prompted with the files that have been changed, and there's issues on that because we would like to give more information to the user. Like, is the grub configuration changed because it's textual? Should we use Git? We don't know. But as of now, like, we have this debate of why should we deal with that? Because if the OS was doing with that correctly, then it would be a non-issue for the whole ecosystem, not just ads.
Yeah, so the improvement in this area is to like have this because currently heads basically verifies the boot files like kernel internal has the exact same hash. And if changes, then user needs to do something. But that could be changed to a verification if it's signed with the same key as before.
Exactly.
So after update, you don't need to resign everything. Grub config is still a bit problematic, but yeah.
But if we're UKI, then the grub configuration will be...
You still have the version in the file name, and
okay.
So grub config would change. Maybe we can abstract it out some way, I don't know. Yeah, but that would be a single file that change and not like 5 of them.
And then introspection, being able to check what's inside of the file, checking if the kernel boot options change, blah, 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 blah. That would be possible. Like if there's work there, your first thing just disappears.
So some comment from Demi. DRTM requires being able to reset PCI devices effectively, so SRTM still has its place. I don't know how to comment that. Linux is not a good choice. That's Demi comment. OpenPGP
is Tiano Core better? Maybe
it looks like the alternative is between those two. OpenPGP is not a good choice either.
Yes.
ED 255 19 signatures are better. Can I assume that the goal is the same level of security as heads, but not a drop-in replacement? That's a question for you.
I would say yes, exactly.
You don't need OpenPGP. OpenPGP should be written in Rust because of how complex the
Thank you, Demi. We know.
But OpenPGP cards can be used without OpenPGP.
Yes. Yes.
So from my perspective, UK signed by ITL solves the signing problem. SRTM and RTM are complementary. Bootloader spec can solve the grub problem. Also, grub config can itself be signed.
So this is kind of extension of SRTM. So you have a USB token that verifies if SRTM measurements are correct.
Static at boot. Prior to typing your password.
Yes,
Ads is basically that, making sure that where you type your passphrase is safe. That's the goal.
Which is kind of similar to anti-VLMate, which use DRTM compared to SRTM. Yeah. So that's, I think, the good summary here. So
you do DRTM with a real root of trust.
Yeah. Well, with bootguard, you still have that.
So no, this is a different place for the root of trust. This is different. So in bootguard you have fuses.
Yes.
And static code root of static code root of trust for verification is in ME. Yeah, correct.
No, it starts in ME.
Or ACM.
Yeah, ME verifies
ME. So and with DRTM you have CPU which verifies ACM.
Yeah, I think so.
Yes.
So the root of trust is not. The root of trust, so according to Christian, who explained that to me, he's saying that in DRTM, CPU is the root of trust.
Yeah,
but
that's what I get.
Then, well, in both cases, you trust DPM, and what other differences we have?
Yeah, that's the main difference. Just want to highlight that.
Maybe just for the sake of the discussion, like what happens there is that basically you trust the ACM blob, which will be loaded by the processor only if it's signed by the keys of Intel, and then
we
the
hope
ACM.
So.
Yeah, that's it. Hopefully, we're trusting another key, but yeah. So the goal there is like ACM is loaded, and then ACM is in charge of the TPM in this weird mode that is the only controller of the TPM. And then it measures the boot block inside of PCR0, which gives us the guarantee that we want. No? Correct.
I don't think the RTM is possible at that early stage at the boot block.
So, I mean,
IBB and everything else.
TXT did measurements of
that's the goal.
But only on servers.
Only on servers.
Yeah. No. I don't know if it is like possible since this convergence of bootguard and TXT, but
this is like slightly going off topic.
Yeah. Well, okay.
And what you as the main developer of heads think of this idea?
So that will also mean re-implementing all the stuff that is currently in Bash in something more sensible.
I would love to duplicate myself. And that's what I would say. Like, if funding is unlimited, everything's possible.
Yeah, the last bullet is the most important one.
Yeah, but I would say this questioning of everything doesn't make me happier for the moment. That's for sure. But like, yeah.
It said happier, not happy.
Yeah.
No, he's already happy, I assume.
Yeah. But I don't think we will resolve that today. But like, it's
we're working on this.
It's an interesting, Questions from the audience? We have 2 minutes.
Maybe sum up. Yeah, I understand that. So essentially, we agree that UEFI is possible. Like the same property or similar properties are possible in UEFI. It will lead to a lot of choices. Like,
just looking at this slide, I think this approach would give you a unique feature of having anti-will made for Windows, if somebody likes that. Because I don't think anything else, well, BitLocker kind of does that, but it's kind of only.
The point is open DRTM because
I wouldn't say it is that simple for at least Intel to perform DRTM with Windows. Like you need this specific MLE header inside the binary you want to execute. So
also then you got the problem you need to integrate this with BitLocker or something. I think for Windows it's I think more complicated.
Right.
No conclusion today.
Yeah.
Okay.
Right.
Good.
Thank you.
Thank you.
Thank you.
could happen if we work together. That would require the collaboration between Qubes OS, probably SecureDrop team here, and Tasket, that I don't know if he will be there in the part of questions later, which is the main developer of Wing Backup. So basically today we're going to talk about Wing Backup in this weird and big dream of mine of so many years, which is save the states as a firmware service. And the question here is, what do we want as a service on that? So this is the presentation of today. As my talk of yesterday, I will go through each of those points, so I won't go through that like right now. So who I am, I'm Thierry Lorion. I'm the maintainer of the EDS open source firmware project. I'm a past collaborator to LeBreboot, Qubes OS since I don't know how many years now, and most of my work is about like granted work. So if any of you have crazy ideas that would get me money or like part-time development, all of my work is about facilitating accessibility and security and confidentiality. Most of my clients are people that I don't know, which are using the software that I do for privacy reasons. So it's always weird to fit the needs of people that you don't know. So what I'm trying to do since a couple of years is like trying to fit needs of, for example, SecureDrop right now would be amazing. I presented FlashKeeper yesterday, and today is about like this WING project that I collaborate for 4 years right now to bring it to the state that it is right now in 2024. So what can WING backup do in 2024? So this is the proof of concept that I did at home. What you have here is basically a Raspberry 5, which is giving you 4 cores and 5 gigs of RAM. The little weird thing that you see just beside is actually a 4-drive bay, like SSD bay drive. The Raspberry Pi is doing SoftRaid 5 on top of that, and this thing is kind of the router that I was using in my apartment to do the test. And the test that you will see in this presentation is actually me doing wing operation through Tailscale from Germany back to my apartment in Canada. So the speed and results that you will see here are kind of interesting because it's reflecting what anybody could do remote. And the Qubes OS community, as I understand it, is privacy conscious people that would not necessarily want like to save state in the cloud, but this is kind of a self-hosted cloud like in your apartment, which could definitely represent as well something more powerful that would be in infrastructure. So I want you to dream on the idea of if you had like a state disk that you would want to deploy on all of the laptops that you have a fleet you're responsible for, what would happen on the firmware level so that you can just boot your machine and say, I want to pull the states exactly as they are up to date right now, and keep in mind that the results that you will see here are the time results that somebody would expect. So we're talking about minutes. So the previous talk before lunch today was SecureDrop workstation, and one of the points that they were raising is like, okay, so we have this use case where there are some users that haven't booted their machine from the holiday period, and then so many updates like happen in that timeline. So how do you know that the user will be able like to update the stuff and then maybe reboot, or that the service inside of the machine will be able to restart themselves after the updates and everything? I think this kind of situation would be able like to resolve this use case, because the user could be prompted to be forced to connect to the network at the firmware level to pull the disk states, or even not have any disk at all when they are traveling, and then buying a disk, putting it inside of their machine, and decided to connect on the network from the firmware, because the firmware is provisioned in a certain way to know which server, which public key to be able to access just the files on the SSH server in read-only, and just pull all of those states. So if you think about templates in Qubes OS as of today, we would talk about like maybe, I don't know, 3 gigabytes of templates that you would have like to pull. So that depends on the network speed. But like the way I imagine it is like I arrive in my hotel room, I start pull the states, I take my shower, I'm chilling, and then poof, my laptop is ready, and I boot inside of a state that I can trust by the IT department. So this is the little proof of concept. And the bottleneck right now is that from this Raspberry 5 not optimized for soft RAID, like for hardware-based RAID, you cannot really write more than 100 megabytes per second. But this is something that I was able to build myself for like $200. So if we wanted to build something or even sell like a cloud-based solution for Qubes OS users, we could work together to do something really more nicer than this for not really a lot of money. So let's think about that at the end of this conference. So I will offer you a choice. Right now, what I'm showing you is just like screenshots. I offer you the choice of talking about like this or me showing you demo at the end, because the screenshots are just screenshots of videos that I could show you, or I can show you the screenshot, the video later. But if I don't show them now, they won't be recorded. So you're deciding, like this is a book you are the own hero of this situation. So sorry about the screen size. What I'm showing you here, this is DOM0 doing the backup situation. This is a capture of what is happening inside of the sys firewall. This is what is happening inside of the Raspberry Pi. And this is what is happening inside of DOM0 at the moment of the backup that is happening. So right now what you're seeing is 42, I think, VM that are actually going to be backed up to the Raspberry Pi from Germany to Canada. This is a session like of 2 days of work when I was staying over. And at the end of it, we see that the backup was actually taking like 6 minutes, 40 seconds. It resulted in 900 megabytes of stuff for 46 volumes. You see that the Raspberry Pi was absolutely doing nothing with, you know, like an average uptime like 1.32 at a time, and you see that the DOM0 was not doing a lot of things either in that period of time. So let's remember that a full backup, as opposed to Qubes OS backup session for an old session of what changed for the past days, took 6 minutes for 1.2 terabyte of data that I have on my laptop. So that is that. The second thing that I want to show you is differential restore of a BTRFS. Oh yeah, so this proof of concept is over BTRFS. It's not LVM. More discussion with Marek on that later. So what I'm showing you here is a sparse write operation. In Wing verbiage, what it means is that you decide of the trade-off of taking more CPU time of your machine that will take all the metadata of the remote backup server, compute the change on your disk as opposed to what you want to restore. So there's a lot more processing going on at that moment, like on the local machine. And then what is going over the network is just a subset of change that is between what was remote and what is local. So in this proof of concept, oops, it will come back, hopefully. Where? Okay, here. So this is one restoration of a personal backup. This machine is 132 gigabyte. This is the confirmation before I do it. What is important here is that the mode of operation is in sparse mode as opposed to sparse write. We will go over that case later on. We see here that the throughput before of the operation is 92 kilobytes. And what I did in this proof of concept is that I removed secrets that were inside of the personal VM. I'm simulating like something like before taking the plane, I want to make sure that I don't have any personal information inside of my personal VM. So I delete that stuff. And then when I arrive at the destination, I decide to restore the state that was in my backup. So this is to simulate, like, it could be the same thing for a template. It could be the same situation for everything. So at that moment, what it says is that, okay, like the last backup session that I have is at that date, at that hour, that VM only. We have to dream of a GUI here, but like the operation is happening in 40 seconds. So 40 seconds, I'm having back all the secrets that were inside of my VM. There's basically nothing else that was transferred over the network than the change of the disk state that I decided to pull. And the machine was working a bit hard here. This is an NV41, so you see that an uptime of 2 based on 12 cores is not the end, but like the OS system is working really hard to make sure that to calculate what was the difference to be pulled on the network. The last small demo that I can show is like a full restore. So in the case like of SecureDrop, that would be kind of it. Anybody that would decide to have like states hosted in the IT department.
Just a question, are your VMs running or not? I mean,
Sorry?
VMs are shut down.
Yeah, you have to shut down the VM. Otherwise, you back up the last state that was saved in the backup rotation. Yeah, it's not live. It's the last state that was saved. Yeah. So here it's a full restore. It's in sparse write. So sparse write here means that you don't care about calculating the change. What you want is actually the state that is actually stored inside of the machine. So when we talk about something clean, we're talking about like the use case where somebody just arrived like in the country, he buys a new hard drive, puts it in the machine, and then we're dreaming about the firmware, doing actually the partitioning, creation like of looks containers. And then from that moment, you're having the policies because it's already defined inside of the backups, like Wing takes care of that, also keeps the properties, sorry, I have a blank, I'm French. The preference of the VM from Qubes XML files are embedded. So when you do the operation here, it's asking you, of course, if you want. Here we are in sparse write mode, like I said. All of this is happening through tailscale, and then the operation starts. And here we're restoring the vault. So I traveled without my vault VM. I arrive at destination, I decide to restore it. And here it took like 2 minutes, but again, like we see that the bandwidth maximum was around 26 divided by 8, around like maximum 5 megabytes per second. Took 2 minutes, and basically we downloaded my Vault VM, which was a total of 230 megabytes. It's ready to go. I can use my Vault. It's there. It works. It's in the state that I want it to be. So there's videos of that if you want to go through that. And why Wing backup over standard full Qubes OS backup? I was really happy to see that there was a slide in the presentation of Marek in the past day saying that there's already an interest like going into that direction. As you've seen, the speed of iteration of a backup goes from, in my case, backupping 1.2 terabyte would take, I think it's overnight. I think it takes like an overnight, which means that typical users will actually do a backup maybe once a week, or maybe not at all. Mostly not at all. So that's it, meaning user would do backups more often, less burden on that. Again, there's a detail that I skipped, but like Wing is really amazing because it does the duplication on the SAN. So here, if we see in the options, all the options would be hidden behind like the GUI, of course, but like we're remapping. Here I'm passing a couple of tags saying like what this backup is actually meaning. So in the case like of SecureDrop would be like latest maintenance or I don't know, whatever, but then all the VMs that are having this tag can be pulled. So for example, your tag would be production. And then like each time that you pull the state, like from the firmware, you would pull like the production state. And what I wanted to show you here is actually that, I don't see it right now, sorry, but like everything that is being sent in dedup mode. So Wing is taking a lot of time and calculation to make sure that all the blocks that he calculates being different will be different amongst all the templates that are actually inside of your backup. So what that means is that, for example, if you have Linux workstation and Linux gateway, if you look at the block level, like those templates are totally identical, but with a really, really small change, which is actually the package related to the workstation. And a little bit less because the gateway is deploying things that the workstation doesn't. But like if you compare like the two templates on top of each other, we're talking about 200 megabytes of difference. So Wing, when it does like its magic, is actually seeing just the change on the block level. So the thing that is calculated to be pushed on a session of backup is actually just the difference between all the templates. So if we talk about Quasal project, for example, which really clones a lot of templates and then specialize templates. In Qubes OS, we push users to actually clone and specialize templates. If you're using Wing, what you're actually doing is just taking the difference between all of the templates. So you're not backupping 20 times the size of your template. You're actually just pushing the difference, which are the software being installed or the logs that should not be there or whatever. So at the end of the day, you're just pushing the actual block difference, which is normally software, because that's what your templates are. In my use case, since I'm compiling a lot of stuff and I have a lot of VMs that are actually the same heads but with different branch compiling different version of core boot or different version like of Linux, like all the artifacts, when I push, and I did, like when I did my backup, when I push the change, it's only the difference on the block levels compressed that are being sent. So if I didn't change anything because I already did that change, or I don't know, if you have the same Qubes OS ISO in 2 VM or 4 VM, it's only going to be sent once, even if you have the same content on so many different virtual machines. So seriously, it's really amazing. So economy of space, multiple sessions over a long period of time. So my first backup that I have on that is from 6 months ago. And each time that I do a backup, I can still restore what was stored 6 months ago. But I can also restore in the state that it was yesterday. And since the backup takes so short period of time, in the same day, sometimes I have 3 or 4 backups, depending on what I'm trying to test. And I can revert super fast in the state that I was before. So if you're really taking the states into account, and if you use tags correctly, then if you tag your things correctly, you can restore in that tag super easily. So it's just a different mindset to implement. It's a challenge in terms of GUI, but that's really making the complete difference. So the dream for heads, even UEFI, maybe IPXE, I don't know. The idea, like I already said, is we have 2 cases here. So we could go in the dream where no operating systems are pre-installed. But that goes with the idea that we have a lot of things to actually fix inside of Qubes OS, including how can we keep track of DOM0 being just DOM0, no logs, no. So I'm referring here to this QR code and the issue where we need to work on those things, because there's a lot of things in DOM0 that should not be there. So more talk about that later. We also know that the content of /boot is really intimately linked to the state of DOM0. So boot and DOM0 are linked. We need to think about that so that there's a way that those 2 things can be merged together. Because if this is accomplished, we can actually deploy DOM0 and /boot as a state as anything else. I see his frown face. He's like, but like if we work there, it would mean that you don't need to install Qubes OS. You can have a clean disk, and then you can pull DOM0 and /boot and the disk states all in one operation, and that would be the dream here. So that's it. What is missing from Qubes OS from DOM0 backup restoration? DOM0 separation of states, so DOM0 backup, boot backup, and Wing backup integration into Qubes OS. And there's an issue there. I think I linked it. Yeah. This is a QR code like on Marek's requirement for Wing backup. The reply just under that is the reply of Tasket. We need to challenge that to know like where we are and what is missing. Wing, 3 years, I did a presentation on Wing like 3 years ago, I think, and now encryption is there. The file system is, the names are randomized. You cannot really inspect what is actually there. The details will be in that ticket. I won't cover that. That's Tasket like jobs more than anything. And the point that is important here, and that's why I'm doing this talk today, is that this QR code is a proposition for a joint grant application in which I'm already involving SecureDrop, like if possible, as the end user that we would want to fill the needs. And if we can work together, we could actually get a grant application so that Wing becomes the standard. That service can be offered like as a firmware service and go forward with that. So that's that. So you have the choice, questions or demo. How much time?
We have some time. 10 minutes.
10 minutes? So you can revise your decision after a couple of questions. Okay, question.
Okay, I have two questions. The one is why in the firmware?
Why in the firmware?
So in a firmware usually is harder to manage. Like you have a tricky update situation and stuff. Why do I mean wing backup and stuff like the great tools, but why do you want to move this into the firmware instead of keeping this in at the OS level?
Because if you're trying to restore a state from the OS level, you have a problem of trust already.
Why? You can load some fresh OS.
But for example, in my case, like if I try to restore from the network, I might do the error of actually restoring a state that I'm actually using right now. So the Qubes rotation like of state, like you know the back session, the revert possibilities might be problematic. You're actually running something that is in a state that is runtime, but you're actually writing in the state that is going to be at the moment of shutdown at that VM.
But still, why do you get like then you suddenly have a firmware which needs to talk to the network, so you need some kind of net VM in the firmware and stuff. Why don't you boot just the system from
an external thing?
From a drive or something? Not the system you are restoring, just where you put all your backups, tools, or whatever you would like to have. Like
but in my first slide, that's.
And the firmware only needs to do your verification.
Yeah,
so
but that could be that. Like it's something that I propose as well, because if IPXE is basically pointing to a kernel, an initRD, whatever. Eds is already having the possibility for on-demand loading of drivers. So like it doesn't change like the attestation or whatever, but if you decide to go in this polling mode or network booting in this case, it's just defining what is best like for the end users at that point. But Eds as of today have the capability to be able to pull on the network, images that would be detached sign, and then key exec inside of them. So like this Python requirement like of Wing, you just need to have like keys. Like it's more like how we deal with the server side from the operating system, how is going to be the exchange of key, and Eds is just a good place to have those states. So for example, SecureDrop would say, oh, this is this public key that you need to have to be able to access the SSH server. And after that, you just communicate through SSH and you pull those states with Wing, but Wing requires Python and Python Cryptodome and ZSTD, basically. That's it. But
Okay.
you need to boot inside something to be able to restore it. And if you're doing it from the operating system, it's
No, I
not
mean
ideal.
like another operating system if you put on a thumb drive or whatever. But okay, the second question, you had this example for traveling. What's your use case? Like, if I understood correctly, you removed your vault before you had
My vault,
traveling, and then restored after you arrived. But that means you are actually traveling with the secrets you need to pull it down. So what's the advantage?
No, I removed it before traveling, and then
But how did you restore it if you don't have the secrets to access it?
I think he's meaning the access to your server, to your backup.
Yeah, you're actually traveling with all the keys you need to access this. So I didn't understood this.
But that
use
proof of
case
concept with Tailscale, it's just details. But like you cannot access your SSH server without logging, permitting the access through Tailscale to your SSH server.
Yeah.
At home. So basically, if somebody was stealing my thing and trying to restore, knowing that I'm using this or whatever, it would be blocked just because he needs to authenticate being me with like a single sign-on before being able to access the services. I don't know if it...
Yeah, I just don't get but what's the advantage compared to a normal encrypted disk where you also need your secret to access?
It is, but like when you access through Wing, you also have to type, like it's hidden like in this detail, but like you cannot just access the backup that is encrypted without your key. Otherwise, we're talking about like states that would be unencrypted because you're just storing templates, for example, and no secrets. We're talking about two things here. So the proof of concept I showed is you could not have any secrets on your computer. Like of the storage that you try to restore, you still have to have like your SSH key because you need to connect. I agree.
Yeah, okay. Can I try to answer this? I think the question goes in this direction that this concept gives you more safety and security when you travel with your devices and are potentially in a duress situation where you put under force to reveal your credentials to the local machine. But if there are no secrets, then you can maybe easily give access to the machine, which typically doesn't apply to some backup servers remote.
Yeah, but I just took like a bad example. I should have restored a template or something. Like it's just that in my use case, it was the best example that I could use because I needed it and I didn't have it. You know.
I think it's more about plausibility, deniability. Like if you have some encrypted data on your disk, I don't know, law enforcement may try to force you to unencrypt.
But you don't have it.
But if you don't have it at all, they don't know it's on some specific server. They don't know the address or something.
Okay, I think I mean that's probably so. Corner case, they probably are not prepared for this, but I think for something like email login or something, I think there are cases where law enforcement actually took the credential from the device and then pulled from the server.
Yeah, but then they couldn't.
If I understand correctly, it's not like you have a key to access your backup on your laptop.
No, it's a passphrase.
Password to the
Yeah, I need to clarify this. Like Wing with encryption requires you to type a passphrase before. Like in the example, like I did it because I did screen caps, but like the first thing that you see. Like in the common here,
but
authentication like backup is like 3 hours just for the sake of doing tests. But like the first time that you use it, it asks you to type. But like in the case of SecureDrop, you would not need encryption in the sense that what you're storing is just templates. So
you still need authentication, some authentication.
Yeah, I mean the secret case. Like I'm not sure if that's really make a difference if somebody forces you to reveal secret to unlock your disk or unlock your backup server,
but they would have to go back to my house. That's my point, because like Tailscale also asked me, they would have like to force me to type that passphrase because having my key is not enough in a remote situation.
Yeah, I think it's a difference between asking to just unlock your computer and they will do some stuff, or which is more common than give a secret to this specific service we know about from something, which is.
But I get your point. Yeah. I get your.
So my question was similar to the first question from Simon. I don't like this thing in the firmware. In the firmware, we do have in Qubes this sysnet separation, etc., to isolate anything that talks to the internet. So now putting everything in a single place that is hard to update because firmware has limited space, etc.
What I would put inside of the firmware is just something where you point to get like the
latest
but you
version. Still have this if you use PXE or HTTP to download. You still to download the actual kernel. You still do that connection from firmware directly. So that's potentially less updated piece of code that would talk to some network service. That's risky.
But we're talking about Linux, so here we're talking about the drivers for tethering, for example. That's an option, and it's actually really cool because, like, on your phone you can decide if you want like to pass through VPN or Tor or whatever you decide.
Yeah.
And after that, it's just options.
There are some mitigation to some of that, but I would say it's more risky than booting your. Maybe we could have enough software in the Qubes installation media, so you boot into restore option or something, and heads already can verify
the signature of the
signature
ISO
of the
1 minute.
I have one question. So personally, I like this project for several reasons because I'm hosting several Qubes servers. So basically, I don't really want to go to each server and trigger the the backup, daily backup, and so on. So have you tried to make some tests about daily backupping? So basically you have some running services, you want to shut it down, backup, and then restarting them. If you do it every day, it should be very fast to back up the difference and restart it. So do you think it's possible to implement such thing like shut down what you do automatically, backup and restore?
That would be in the cron, and there's an issue open requiring participation from people using this use case into how to cache the secrets or how to talk to a secret providing services, because the problem is typing your passphrase, otherwise you cache for a certain period of time, which may or may not be desired depending on
because in such case it could also be some remote VM declared also inside this, and we can.
Yeah, I think for the caching passwords or something, NitroKey will have some answer.
Great.
But for shutting down VMs, that's actually another point. An alternative approach is to not shut it down, but just pause, do a snapshot and restore it. From the, if you restore backup like this, it would look like it was like
corrupted,
forcibly shut down.
But you have to sync before pausing, or
something like that. But it should, like, most file systems are safe against like sudden power loss, so it should be fine. But
Tasket doesn't like that for some reason. Like, I challenged over and over. I mean, if you pause, the rotation system inside of Qubes, you could actually back up the live version instead of shutdowning, but it's
you can just take a snapshot from the volume. You don't need even to pause it. You can just make a snapshot.
If it's atomic, yes.
But I think RVM or something should be.
It should be, but there's difference depending like of LVM and BTRFS. Thank you.
So hello, my name is Piotr. I'm working on stuff on Qubes OS, and today I'm going to talk about the incoming advances on handling of peripheral devices in Qubes OS. So this is the outline of my talk. I start with some common mental model of common user of any OS, how to handle the peripheral devices. Then I will talk about the previous design of handling peripheral devices in Qubes OS, and I will present some motivation for changes in this design. Then I will go more into the details, what was changed and how to use it, what is the benefits of that, and then we, of course, have some summary. So at the beginning, the simplest mental model of the peripheral device is something like that. I have my computer, I have the device. I plug this device to my computer. The system noticed that this device is now available, and I do my job. And this is what is the perfect world. This is exactly what I want to do. It's simple and quick, but not entirely safe. Because, for example, if this USB stick or even USB cable, it's not really USB cable, but could be keyboard, and can inject some keystroke to my computer. So it's not really safe to attach everything to my computer when I keep my data. So in Qubes, we have to add some additional layer, additional step between to keep things isolated. So I started with some plug-in to device to USB port, or creating the block device in some backup backend VM, and then this VM and only this VM see this device, and to make it visible to any other domain, I have to type this or use GUI, of course. This attach QVM USB, for example, attach command, which take the backend domain and port ID and decide to which frontend the device should be attached and available. And usually we want to attach some devices to some VMs, and we want to keep some VMs without any external devices for security. Of course, we can also detach the device with the detach command. And this is also one more option. In the previous design, we also have the --persistent flag, which means that this attachment is not only single time attachment, but it's some type of assignment of this device from this back cube will be always attached on the startup of front cube. Okay, so when the front cube is starting, is looking for this device at this backend cube, and if this device is available, it will be automatically attached on the startup, and if it's not available, the startup of the front-end domain will be stopped. Okay, and this is how it works up to now. And there was some problems. First of all, this persistent options was a little confusing for USB devices. It's not perfectly made for them. It works okay for PCI devices, but not for USB. And for example, when the Cube started with a device attached persistently, and then we unplug these devices from our computer, in the system, this device is still attached persistently, but in real world is not even present. So it was a little confusing what happens there. And also about some internal stuff, this persistent attaching also generates some events that some new device is attached, but in fact no real device will be attached. So that was confusing. The second motivation, that's this mental model of the user. If I have some physical USB device, I'm thinking about this device as this is the physical device. It's no matter to which port I would plug this device. It should, because when I'm thinking about the peripheral device, I think about the device itself, not about the ports. But in terms of Qubes, we identify device only by the port. So if I have the USB stick A, let's say, at the port 111, and the partition of external disk D, which is visible as SDA 1, and I persistently attach these devices to some front-end VM, and then unplug the devices and plug into the same port USB stick B, so different one, and some different external disk E to any port. These partitions of this disk E will be also visible as SDA 1 because there is only one block devices there, and both of these devices will be automatically attached to the front-end VM, and this is confusing for many users because when somebody wants to try to persistently attach some devices, they don't necessarily want to attach any devices, any different devices, plug it in the same port. And the last motivation is also maybe not accidental, but unintended attachment. So I have some front-end VM, for example, with my secrets, and I do not want any devices to be attached there anytime. But sometimes, by mistake, I can attach it by misclick or something, and this is something what we want also remove. So, okay, the first part, how we solve the confusing persistent option for USB devices. We split this attached device into attach and assign section. So for now, attaching is only for the attaching actual existing device to running front VM and nothing else. It doesn't work for the PCI. Of course, we can do it for PCI, but there is no much sense to attaching PCI devices to already running system because it probably doesn't work at all. So let's say it's blocked. And assign, in contrast, it's something that say that whenever the device is discovered in the system or the front-end VM is started, the device will be automatically attached to that front-end. Okay, there is also no good reason to assign the devices. What is important, if this device is not discoverable during the startup of the domain, nothing happens. Just domain started as always, but without that auto-attached device. It's very convenient for USB. So if I assign my USB stick or microphone or something to my front-end VM, every time I will start this front-end VM, this device will be automatically attached. Or if this front-end is already running and I plug the device, it also will be automatically attached. And if it's not, there is no problem. We also add the flag --ask, which the difference between assign and assign with ask is that before actually attaching anything, we will be prompt. The prompt looks very similar to every Qubes user, where here we have the source of the device, so it's the backend name, it's the port number, some device description, and we can choose the target where we want to attach this device on the startup or whenever. And the last option is the assign required. This is almost the same as attach persistent. It works in the same way. Moreover, there is existing alias that attach persistent. For now, it's the same, which is assign required. So it's assign the device as required. It means if the device is not available during the startup of the VM, this startup will be stopped because it's because of lack of this device. It's the right thing to do for the PCI devices. If some devices should be attached to, for example, sys USB and there is no available USB bridge, the startup will be stopped. But it's not allowed for the USB devices because there is too much confusion about that. The second motivation is the confusing mental model of peripheral devices. So we introduce, let's say, device identity. There is just 4 simple information which is already presented by almost every devices. So this is the vendor and product IDs. This is the and this all information here is provided by the device itself, so it's as trusted as the device. There is optional serial number. Many USB devices or PCI has this serial number, but not all. And there is so encoded interfaces of the device. This is the example for the PCI and USB devices. It looks like that without the serial number. And this is the device identity for the block devices. So this is the first part is the parent ID, device ID of the parent device. The parent device of the block device could be the USB device, for example. So if the USB stick has some block devices which has the partitions, the parent of the partition is the whole block device, and the parent of the block device is USB stick. And all this information is here. We can even see that this example, I have the USB stick, which on the second line, this is the device ID. For the whole block devices of this USB stick, there is the device ID, and for the first partition is additional one here. Okay, the question is what we can do with such device identity. First of all, this device identity is not unique. There could be, for example, if I buy some cheap USB stick, there is a high probability there is no serial number there, and two such devices is treated as equal. But it's not that bad, because in fact, if we have two devices which looks exactly the same and they presented every data as the same, there is no other option to see any difference. Even if you do it manually, this is almost the same device, and we cannot do it better. But if you have some better USB stick, especially with serial number, that's very good, because it's really hard to spoof your serial number. Somebody have to steal your USB stick and have the physical access to it. And if somebody actually can have some physical access to your devices, I think this is not your biggest problem. Okay. And how it works, how we can use it. For now, if I type something like assign, and I put the backend cube and the port ID, what will be really assigned is not only the port number, but also the device itself. So it means if I now put a different device to the same port ID, there will be no auto-attaching. Also, when I choose a different port ID and put this device there, there also will be no auto-attaching. The only way to have this device auto-attached, I have to put this exact device or identical device to this exact port. Of course, I can use the dash port. The difference here is now this device is green, here is device is not green, so we attach only the port. So any device which will be attached to this port will be auto-attaching to the front-end VM now, because I only assign the port, not the device itself. Also, we have the flag -- device, which now ignore the port and attach only the device. So it means if I do something like that for USB stick, this doesn't matter to which port I will plug in this USB stick, there will be auto-attaching. There is also some additional options. So instead of flags, we could use some wildcards or directly put the USB or block device, PCI devices identity there, and that works. And this arrows show that this option is considered as the less safe, because there is the highest probability that something goes wrong. We have two identical devices and we accidentally attach to something where we don't want. And this is the safest options, because we need the identical devices and we need to put it in the right port. So it's the most restrictive one. And the practical usage of assigning by the device ID, that I have two USB sticks, and in sysUSB they expose block devices SDA and SDB. If I run something like that I want to one VM assign the partition SDA1 and the second VM partition SDB, but by device, then when I replug these devices in different order, so the enumeration of the block devices will be different. So for now, the first USB stick will be exposed as SDB and the second one as SDA. What happens? The SDB one will be attached to the first one. So here was SDA1, and then SDB will be attached, because we don't care about the ordering of the block devices, but we care from which device this block device is exposed. Because in the previous one, in fact, auto-attaching of any block devices from sysUSB was not very clever idea, because there could be any devices, let's say random devices, could get SDA in sysUSB. Now it will be checked if this block devices is exposed by expected device. Okay. The question is, what happens if I do something like that? So I tell that I want to auto-assign any device which will be plugged to port 410 to some Debian, for example, and I particularly want that this one device will be always auto-attached to Devel Fedora, for example. And what happens if I put this particular device to this particular port? The answer is prompt to which front VM this device should be attached, because there is the conflict that both this assignment is valid. So let's just type what you want. Of course, there will be the list of the possible acceptable front-end VMs. This is the list, the new list. Maybe we should add some flag to filter by only attachments or only assignments or something like that, because for now we can have some lines twice. For example, here, this device DOM000D is shown like the already attached some PCI device, and here we have the presented assignment, existing assignment, that any device which will be discovered in this port will be automatically attached to sysUSB with the following options. Also, we can do something like that, that for sysUSB, we can take this device, if this device is plugged in, for example, my USB stick is plugged in any port in my computer, it will be asked to attach. So I will be prompted before it will be attached, unless it will be attached to this one particular port, then there will be auto-attached without any asking. So something like that is possible. Okay. And the last one, we introduced the device deny list. It's very simple. The first column here is the front-end cubes names, and then we have the space-separated encoded interfaces. These interfaces could be found in HW data directory for USB and PCI devices. U at the beginning stands for the USB device, P for the PCI, B for block devices, M for the microphone. And here we can, for example, say that we do not want any keyboard attached to my work VM1, or I can say I don't want any HID devices at all at my VM2, or at all any USB devices. Also, there is possible, if we put the 7 stars, there is no any devices at all can be attached to that front-end VM. Okay, and what is important here, this only apply to manually attaching. So if I prompt something like QVM USB attach something, and there this device will have one of these interfaces, this attach will be stopped, but the assignments will work as always. So if there is assignment of devices which is the keyboard to VM1, it's still working, but only automatically. I cannot do this manually. And moreover, if I will create the assignment for such devices, when in device list already is the rule against that, I get the warning that I should double check if this is really what I want. Okay, and the last one, if we want to have some VM without any possible attachment at all, we can do something like that. So nassign, remove all the existing assignments to the VM. So if we remove all the assignments and we put something like that to deny list, we cannot attach anything manually, and anything will be attached also by assignments because we remove all of them. Okay, the good information is that this new device API is fully compatible with the old one by aliases, etc. So everything should work without any additional effort. And to sum up, the new device API gets us more grained control over peripheral devices. It's easier to keep our cubes and devices more isolated. It's very convenient for automation, especially auto-attaching stuff, and hopefully it's less confusing. So that's all from me. Any questions?
Hi, thanks so much. That was a great talk, and I'm very excited about all of these features. I'm already thinking about tons of code we can delete, and it'll be easier for the user experience. So I have a couple of questions. My first question, they're mostly about the deny list. So the first question is the deny list the only way to specify which VMs are allowed and not allowed? Like, for example, will there also be like an RPC policy way of specifying? And yeah, actually, that's the first question.
Okay, we are not planning to adding any additional RPC policy for that, just the deny list to keep it simple, and I think it should cover cases, but maybe will be the good case where you cannot use just the deny list. We could consider to add something more.
Like, for example, I'm thinking about the 4.3 UUID-based QRexec policies, and I'm wondering if it would be possible to have like deny list based on UUID of a VM instead of on the VM name, but I don't know if that's too far in the future.
It's too, yeah, we have to think about that.
Cool. Thank you so much.
Hi. Yes, so the deny list, is there a drop-in configuration folder for that, or just a single file?
For now, it's just single file. It's just, let's say, the first version. Probably we have to create some GUI for that and maybe make it a directory.
Okay, and the other word, is it a keyword, or is there something such as any VM that is denied? Like to deny every other VM, like is there a keyword for that?
All VMs?
Yes.
No, but
okay.
Maybe it's a good.
Like in some sense, it's similar to her first question, like the interaction of the QRexec policy. Like, does it still require the QRexec policies such as USB attach to be in place, and if the list is checked before or after the policy is done?
I think it's checked before.
Before?
It's hard to say for now.
Okay, that's it. Thank you.
With the Vault deny everything, have you considered shipping that as a default configuration?
Default, like...
so deny attaching anything to a Vault cube, the Vault cube you have on installation?
We can think about that because it's like the only creating the deny list at the beginning during the installation with this Vault, but you know, in fact, the Vault is not any special VM, so.
Is it not? Yeah, I got the impression it was. It's intended to be detached, so it would make sense to have that sort of policy there.
Yeah, but if you,
just a thought.
You know, if you rename your Vault VM, so
yeah, it's just about whether Qubes would want to supply an opinionated configuration.
It could be consideration. Yeah, yeah.
Thank you.
More question about deny list. This was already asked about a bit more extended syntax, like any VM or maybe some tag. Any VM with this tag should not get some particular on any device, for example, that could be useful. But how does it relate to ask? If you ask to the target, is it also considering the deny list to exclude this from selection?
Asking is the auto-attaching, and auto-attaching do not take into account the deny list.
But in ask, you only have to select target from those who have this
assignment exists.
So you need to have assignment to be to see on this. Okay.
For the device ID, is there some option to extend this? Because I mean, some devices have multiple IDs, or for example, for block devices, you might also want to have the UUID of the file system or something like this exposed.
There is no problem. This is just the string would be put in as an identifier, so we could put everything there.
Can you already match just the part of the string, like when you have multiple IDs in there? Can you partially match the string? Or how does it?
If I don't get.
Okay, maybe.
Okay.
Okay. Sorry. And if there was a wish list, I would like to ask for like some of the QRexec notation policy. For example, adding tags, so I can tag cubes and then being able to have not be assigned.
Okay.
That's it. Thank you.
Okay.
everybody. Hello again. Everybody. People are not ready in the room, I'm sorry. So yes, again, I'm Thierry from Insurgo. I'm the maintainer of the EDS open source firmware project. Today, the goal of this talk was a call for opinions from the downstream. A bit of vocabulary here when we talk about upstream, it's like the main project, and downstreams are the forks that are using those projects to actually integrate and deploy in more tested releases. EDS is a rolling release. What it means, and I'm really happy about that because of past funded projects, is that EDS for each commit that are published inside of a PR comes attached with reproducible runs. So thanks to the past funded project with NLNet, we were able to create a reproducible Docker image, which is able to create reproducible runs for each commit, which means that in the future, since that moment that PR was merged, it means that for any moment in time, if you use the same commit of EDS, you will be able to get exactly the same bit-by-bit runs that are produced. So that is that. Now the problem is that when we are selling products, we need to have something that is not only like tested by the community, but we also need things to be supported and considered like stable. And the problem here, and this is a discussion, so I hope people will come in front and discuss with me, because we cannot expect like the downstream release that create products and self-support for those projects to be necessarily in line with what is in master. So when we talk about a rolling release, my customers, like the open source users, are actually beta testers by default of the project. They want the newest features, they're willing to actually download or compile ROMs by themselves, creating the same reproducible ROMs. And they're happy of using some release in time that are different. And if they want something or they realize that there's a bug, they go up on GitHub, open an issue, and then I work on the issues that I'm aware of for master. And then later on, the downstream release, NovaCustom, NitroKey, other players will decide they have to decide which commit they pick inside of a release, and that needs to be decided in advance. So this is where the challenge is, and this is where we try to figure out what will be considered inside of EDS a feature freeze, or what do we decide, when do we decide that everything that is in development is kind of paused, so that we give time for the downstream forks to have releases that are automatically tested manually, cause no regression, works for Qubes OS, works for other operating system that changed like kernel versions, and then like /boot cannot be like mounted anymore because they decided to put a new flag inside of ext4 for orphan files, and everything is magic like in there, but it means a lot of maintainership, synchronization, and that's the base ground for the discussion today. So what do we want for a future freeze inside of EDS so that downstream projects can pick EDS upstream commit? That's the question we need to answer today.
Yeah, maybe some more background from the Shara side. So our point is that we have a team, we have a budget, we have to schedule things. We cannot be like a rolling release. We cannot afford rolling release. We cannot afford making every commit a production quality because like we have 350 tests to execute every release, and essentially like cycle takes 2 weeks right now or something like that. So we cannot do something like that. So the point is right now some situation happened that we starting release cycle, and then we face a bug. Then we going to Thierry saying, this is, or 2 hours later, Thierry was sending pull requests, everything is fixed, and say, this is fixed. And what we do, we're getting back and starting from the beginning, Yeah, but because we have to validate if nothing was broken, yeah? Or shall we continue? Shall we ignore? Shall we just like assume that everything is fine? This is not production quality approach, yeah? So, yeah, so, and that's problem. So if someone have experience dealing with rolling release downstream, like rolling release upstream project, doing some downstream stuff, I would welcome feedback how to deal with that. So current approaches, like yesterday discussed with a lot of beers, and not only, is to introduce some kind of freeze. So first of all, we're going with, let's say we want to introduce some bug fixes in given release of Dasharo, because the Dasharo got releases, Heads right now don't. So we essentially, okay, we will fix this and that. We run single test against those bugs. If those are fixed, then we're deciding that we at like fixed point, let's say once in a year, twice in a year, we're starting to run the cycle. Now the problem is what if the cycle will not get through? It should get through, but like, the problem is what it will not get through. So what we're doing and how much we can afford of that, because that's essentially money for doing the release, yeah. So but at least those, let's assuming that those bug fixes were fixed, so we have to freeze things at this point, and maybe only introduce the fixes which are needed to get through to the end of the release, not introducing anything else. This is like a feature freeze that Thierry talking about. I guess that's some idea. I don't know, like, do you have any better approach to that? Anyone?
This surely doesn't resolve your problem, but could make it a lot easier if you try to get as much as of the stuff you are testing into the upstream project, so that when somebody pushes to master, you have some CI which runs those tests which you can do against master, so that that surely doesn't work for everything. You still have your problem because what you have developed on your main project is not exactly what you're delivering, so you still need your own testing, but you can rule out a lot of cases if you manage to get
so I would say like so one problem is a business value of that, because like that's basic business value of Dasharo, yeah? That we're doing the validation and that we confirming the stability. If we will upstream all the, like, so if someone wants, everything is open. They can there's open hardware that driving the hardware. Tests are open. Everything is open. If someone wants to do that, but I would tell you like this: BIOS business is a function of validation that you can handle. That's it. So we're doing this for 10 years. We have a lab, 3 racks of hardware, people assigned to maintain that lab. I'm not sure if we are ready to expose that to the public and get.
To me? Can that be exposed to me?
To you, yes, I think that's possible to expose that to you. But the problem is that laptops also got these problems with some interfaces, and some tests cannot be run automatically.
Yeah, so a bit of, I guess you answered some of that. So yeah, from what I've seen, a lot of those tests are manual. And the current approach in Heads, I think, is there is CI that is building stuff, and the testing is by Thierry putting a comment, pinging several maintainers for different boards. So all the testing upstream is done manually. So it's not really, like in this workflow, it's not realistic to have every commit tested that is...
But near our feature freeze, for example.
Yeah, but for the feature freeze thing, it could be like some agreement with the release cycle upstream, like, I don't know, every few months there is some time where development happens in pull request, but only bug fixes are merged. Maybe something like this could be agreed. But if not, then downstream could have a branch on their repository where, okay, we are preparing the release, so let's start with some specific point in time and only cherry pick fixes to issues we hit specifically, and not like not everything.
But that means
it's some extra work. I know. But
so I guess we were at at something like that point, but essentially we get into discussion when because like not all the fixes are so separated. Yeah, and sometimes you have like spaghetti dependency between things, and suddenly it's some mindsets. It's not calling the names here. It's like you have this bug. Okay, so you have to fix this, but this is not really fixed because you need this, and this. I have everything I developed, that's fine. So we're essentially getting to the most recent code because that's the best way. And maybe some couple open pull requests because those are also important.
Yeah,
so, but that's what we dealing with here. We have to even sometimes admit that we doing a release with known issue, and that should be okay because if someone really cares about that, they will poke us, and in next release we will make sure that it will have higher priority. And by the way, this is like on the other side. This is open source. We cannot give you even you paying for the Dasher Core Boot Plus heads. It's not like we earning so much money that we can fix everything. It's not that. It's not like that. We're trying to create a sustainable ecosystem with that, and this is still kind of experimentation of how this will happen.
Yeah, having known issues is also some approach to deal. If the fix turns out to be very complex and backporting, taking the fix has a greater risk to introduce even more severe risks, bugs, then it's having some known issues also an option. And the complex backports, I know the pain.
No, backports I don't think will be possible. That's the thing. We need a feature freeze because of that. Like the way I'm thinking it right now, if you were choosing like the commit right now, it's stable with problems with crypt setup, like with things having changed to Lux2, meaning people deciding like to inject a key would use the whole less secure like key release, and so that would be a known limitation.
Marek, but do you have like a practical example working with moving with a rolling release, like kind of approach, or not?
Yes. We specifically decided to not support it officially because we use Arch Linux for that. So Arch Linux is moving very fast. And it's great because Arch Linux community reports they hit some issues before they hit any other distribution if there is some maps. So yeah, but for this specific reason, we don't officially support Arch Linux on Qubes because we cannot keep up with fixing everything, following every change they made. Yeah. It's unrealistic for us. So,
okay.
So sorry, I don't have solution to keep it as.
I just wanted this is design session, so maybe who knows? Like if you're asking, maybe you'll get the answer.
Yeah, this is more of a question. But when you're talking about downstream projects, so the way that I see it is the people who are kind of like who have these downstream projects basically benefit from a stable version of heads. But what happens if someone wants to, like, if someone doesn't have an officially supported product of one of these downstream projects? What if they want a version that is known and they can't keep up with all of the latest updates? Would it be that a solution would be for various vendors who are interested in having like stable versions collaborate on basically like creating versions of heads which are known good versions?
But this is what Tasharo sells as a service, right?
Yeah, but it's too different. Where I would have one word to say there. Like it's basically is using the work of the core boot port in a version that is known based on their release, But the problem is the chicken and egg here, because like when they release core boot plus heads, it's necessarily with an older commit of heads in their release. And then I pick that upstream, and then heads starts to change, being the rolling release, to the point where they need to put like a bug fix, whatever, because then their users are facing, my users are anonymous. They don't report a lot of bugs. Like they are people using it because they compile stuff by themselves. Like it's a weird community. Then their users starts and create issues in their repository for an older version of things that may or not be fixed, and that's where the race starts.
Yeah.
That's the problem.
That's the same stuff like when you talk about what we taking into the release. Yeah, Coreboot, for example, we will not take we will take some tag which is like arbitrary quality in Coreboot. Like there is in Coreboot tag does not mean anything. It's like just arbitrary point in time because managers complain that there is no release in Coreboot and yada yada. So that's why they have, because to be honest, they don't have comprehensive validation. I guess in the Linux kernel, to some extent you have similar, but there are a lot of organizations already doing the testing.
Yeah, but for kernel you have these release candidates and people.
I know, and there is a question if this works and so on. But the Linux kernel is so rich, so big. There is no way they will test everything.
Yeah, of course.
And they introduce regressions.
But there are also a lot of people testing that. If you take a look even at point releases of those stable kernels, which have also release candidates for, I don't know, 2 or 3 days, a very short time. They have a list of people that reported it testing, and it's usually over 20 entries for a single.
Yeah, it's the size of the community. It's a function of the size of the community.
Yeah, of course. But in Qubes we do test RC kernels, for example. So we also report.
But as an example, I'm just giving. This is slightly off topic, but on LPC there was a case of the peripheral firmware, and Grant said that we cannot support that because there's no validation infrastructure for that, and how we will know that those peripheral firmware will work after some time, after next release. So I guess this is similar problem that we have this validation infrastructure, we build that validation infrastructure, that's our job to deliver that, but that means we have to freeze versions at some point because we have to start release cycle, and we have to just say that not everything's coming in.
My insight is checking what Graphene OS is doing, actually, because I find their model pretty interesting, but it requires people from the different communities to actually join the beta testing effort. So, for example, if we arrive near a feature freeze, it would require like both your community, like all the communities like downstream, to throw users at me.
But I started this program and announced that on last Dashar user group that we starting the beta testing program. It worked quite well in NovaCustom. I would say it worked like it exceeded my expectation because there are very engaged people in the private invite only beta testing group. They getting RC, they are not afraid to flash and to recover the devices, and it's going very well. Thanks to that we fix much faster, we have better coverage. I would say that would be definitely something to run with this, and plus this release cycle with feature freeze, but we have to precisely agree about the dates,
the cutoff. Other insights?
So I don't know if this is any.
But I like it. Okay, I'm okay with it.
So when you basically and have the same situation with core boot, like as you said, the tags are more or less just here, so tag a point in time. Otherwise, it's also in practice a rolling release. To what extent is heads different, or do you just want to have better cooperation for heads?
Heads just right now don't have this like fake releases, that just like it would it was and then on the other side like we control the core boot side. So when someone coming to us and we know that this was on this core boot, then we know how to behave with the upstream. We know how to deal with that because we're doing this thing. And if this happened with heads, then as for rolling release, answer is always the same. Use the latest version, yeah. So.
Yeah, but don't you get the same for core boot?
I do, like, because outside of the forks, like, there are a lot of regression reported on, because I don't own all the platforms, so I rely on testing from the community. And it happened a couple of times in the past where, you know, S3 resume doesn't work, interrupts are...
We can achieve biggest stability of core boot because we doing also UEFI based version. And thanks to that, we have, it's quite solid, yeah? When we're doing a release, core boot, -r core boot plus UEFI, it's already, like, validated. So if we're then taking the same base to the heads, we can just you know, a bunch of stuff is already verified. Yeah.
Yeah,
but we're not basing on core boot tag. It's not like it's precise core boot tag. It's core boot tag plus our stuff. Yeah.
Yeah. I think the difference here is that you have a few core boot developers, so in many cases you also do fix the bugs yourself.
Yes.
Instead of like just picking a different version or something.
Yes, yes.
So that's also a huge difference here.
For ads, like, we had to skip a couple of core boot release because the bugs were not fixed, and we just skipped the version until the regression were fixed, and that was it. But it's a different story because ads is not just like one upstream. Like, we depend on 4 forks, I think, like, of core boot right now. So there's this situation now, but I also, that's why it needs to be clear, because if I do a freeze, I'm fine with the freeze, but I just have to communicate in a certain way.
Yeah, sure.
That's it.
Sure.
Other insights? No.
What else we can do better in terms of, okay, we will do this freeze.
I need input from downstream, like I said, like that. This is something that will help me, like the things that are reported the most and you know, the issues and everything, they need somehow to get to me so that I know that at least it's fixed upstream. You know, like, and then we can arrive like to the date without like worries and everything. Feature freeze, beta test.
Yeah.
Go. You know, that would be my way of seeing this.
And then the question is how to handle like users and their issues, because that's something that could be confusing, you know. Because then, like, we will choose some heads version, we will fix what we can fix, we will provide the test results.
Known issues.
And our known issues, and our normal kind of communication is like this. So for -r core boot plus UEFI, if user coming and saying this doesn't work, yeah, then we're going to the test. There's like 350 tests, and saying if this was even covered. If it was not covered, we're saying, I'm sorry, this was not covered, we just didn't catch it. We can plan for the next release that we will add this test. And then, of course, test will fail, we have to fix the bug, then it will pass, it will extend the test scope, and then we will make sure that within further releases it will not happen. But then the question is when will be the next release, and sometimes it can be even in a year, because we plan, the Sharo plans to do like once in a year releases. We would like to do more, but the problem is either you support more platform, either you, I guess automation is one thing, but with the laptops, like it's harder and harder. So Google, I guess, got dedicated devices to, and they designed these devices themselves
for testing.
Yep. So it's not easy, that part.
Marek, do you have insights on that? Like your automated testing, OpenQA, blah blah blah.
Yeah, so we also test on laptops, and we have a large part of that automated. But yeah, there are, especially with interaction with firmware, it's not easy to automate. We mostly interact with the system via USB. So USB keyboard, mouse, you know that I request that feature. And to grab the output using HDMI output, which on laptops most cases then firmware don't put anything on the HDMI. So that's problem with interacting with firmware right here. If I would really need to, I would probably look into like using not USB but actually plugging like fake emulated keyboard and
yeah, we're doing this PKVM, this kind of stuff.
So recently I've finally got working emulated PS2 keyboard, so I have tests for USB and PS2 keyboard both.
That's also a thing that we have to talk about, but this is...
It took some time to get it right. There were some timing issues, but I have it working now. But yeah, I would recommend more automation, because then you can, even if you add one more test, you can run this test on all the platforms. So it saves you time not only running this particular test once,
but the point is
everywhere.
Do you expose your lab infrastructure to the external world, to the CI of the public CI, and expose those results?
Results are you can browse them online.
But I'm saying, like, let's say someone setting up the pull request, does it trigger the CI?
It doesn't do that automatically. I can select which pull request should go.
Test, blah, blah,
Yeah. So there are some unit tests are run automatically, but just some mock-up environment. But the full OpenQI run, I schedule manually. There are various reasons for that. Not all of them are technical.
We could automate that.
Yeah, we were on that path with Trenchboot, but it was easier because there were platforms which could be completely like over serial and this kind of stuff.
For laptops, I think of maybe not all, but for most laptops, I do have serial console for debugging. In some cases, I simply put the PCI device with serial port. There is M2 slot. Sometimes there are two of them, so I don't need to disconnect the disk. So that's really helpful for debugging. There is the one on USB, the XHCI debug capability, something. There are ways to get a serial output. So that's
so debug version instead of S.
I guess that's also the problem. Like, you have to have different build for that.
No, that's not a problem. I just
I
know what I need
but you're not releasing that one.
I have it. Have a runtime switch for that, but for firmware, it's probably not that easy, I guess.
Yeah, you will have separate build for that.
Yeah, but in ads it would just mean another board, including the config options that are necessary, and that's it. Anyway, we can talk about this, but those builds could trigger a CI for testing for pre-release, like in the freeze. Anyway.
So just to make sure, like, the CI triggers stuff on real hardware in your, and then how's the feedback loop? How the results coming back? Like, I know they are published, but do they return result to say, this pull request cannot be merged because you're failing on this and that target?
So
they're not connected.
We have infrastructure for that. If ever there will be a time at which all the tests pass at the same time, yes, we'll make that blocking. But that never happened before.
I see. So there is some.
Currently, we have some tests that are unreliable, so sometimes they need to be retried or something. But basically, there is a human needed to review the test results.
We have the same problem. Even if we run overnight automatic.
That helps.
Even if overnight we run automatic suit, then we can end up with false positive because I don't know, energy from the sun or never. I don't know what's. So some small letter in serial was eaten during the transmission, and then like string not matching, and and it's
but
saying.
Also there is a question of scale. I have a bunch of machines. And every now and then I run into hardware issues, like I have a bunch of Raspberry Pis, they use SD card and SD cards dies from time to time.
Yes.
I have issues like that, or some, power supply in one of the laptop dies, or the thing that press the power button was like, I used, in many cases I have double-sided tape and it's like fell off and stuff.
So with three racks of hardware for automated testing, we have one person full-time hired just for that.
Yeah, exactly. Yeah, so you know the pain. Yes.
Yes, that's essentially what we're taking money for. So yeah, but anyway. Yeah, I guess like the exposing have to happen, and we're going in that direction. We're also going in the direction of better automation and integration with the CI, but this will happen at some point in future, and not now.
Yeah, so I was mentioning we test our release candidates for the kernel. We have a bunch of tests that are hardware specific. We would not test release candidates for kernel. We don't test everyone, but every second or something without automation. There was a time where we tested new kernels manually only, and we definitely wouldn't do that for release candidates. Now we have many of those tests automated, and we can, like, testing a new RC kernel is just a matter of posting a magic comment into pull request, and CI checks if that's authorized user, and then put that into OpenQA, and magic happens. So yeah.
Okay.
And then somebody needs to review the results. That's the only actual manual work needed.
No, I think the first step, like if we have a RC, like I like this idea. Like basically everything that is not fixed or is pull request waiting on draft is gonna be part in known issues. And after that, like you give me access so that I can start the test, like we iterate on that, like manually approaching feature freeze, bug fix, selecting commit, then automated testing, and then release. That's kind of the plan.
We had to write this down.
But it's recorded.
Oh. Yeah. You're right. Okay. Any other comments?
So that's the plan.
Yeah, I guess that's it.
All right. Thank you. Thank you.
worse. Okay. So, round of applause for Freedom of Press Foundation. Thank you very much for sponsoring. Another round for Mulbat. And if someone wants to go for a beer, I guess we can meet here, or we can go in other groups to whatever your location. As I said, we meet tomorrow at 10 a.m. on a hackathon if you have some ideas. If you will not be with us because you were interested only in conference part, we invite you for the next year event. And of course, thank you very much for joining us this year. And round of applause for ourselves, because this was a great event. Yeah, and wonderful team, technical team. And that's it. I think like Qubes OS Summit 2024 conference part is finished. Tomorrow we have hackathon. Thank you very much. Bye-bye.